Hello, good morning. We still have a early starting Twitch ads for everybody not being able to see, but I think some of you can still see. So we'll sort of like just chat, say hi before we begin. Truly, Albert, hello. How are you doing today? Are you getting ads or are you able to see? It's hard to tell with Twitch sometimes. Because like it claims it's doing ads right now. But I don't know for certain. You find you're cracking a zip password to get access to the latest C23 draft. Nice. Well, good luck with that. You've not gotten any ads for a long time. Well, that's perfectly fine. I'm okay with that. If people don't get ads, Twitch thinks that it gets ads. And then that means that pre-rolls are off for everybody. I am happy with that. I think that's great. And then we have no, as far as I know, there's no pre-rolls. I mean, there might be pre-rolls for YouTube. It's hard to tell. I don't have any mid-rolls on though, so that should be good too. Blah, hello, good morning. How are you doing today? All right, and you know what? We also have Cat. It is very cold here. I don't know if any of you who are not in the United States are paying attention to the weather over here, but Canada has decided to send us a present. And so we have Arctic winds. I guess it's actually not Canada. That's Arctic Circle. So it's the North Pole has decided to send everybody a gift. I guess they sent it to Canada first, and then it's gone down all the way to past here. It's Midwest. It's everywhere. Everywhere is getting it. Now, some places are getting a lot worse than others. So to give an example, right now in Colorado, around sort of general area where I am, it's -4 degrees. Now, -4 degrees, this is Fahrenheit. Remember that Fahrenheit freezing is 32 degrees. And in Celsius, so like 32 and 0 are the same from Celsius to Fahrenheit. So when we're -4, that is pretty cold. To the point where they've been telling us that, and wind chills. We got an alert. Wind chills can be up to down to -35. So it's one of those things where they tell us go outside only if you absolutely have to, and if you do have to, any exposed skin, you can get frostbite on it within 10 minutes. Wait, you just got some ads now? It's literally told me everybody's done with ads and nobody will get ads for another hour. It was supposed to do ads before we started. You'd be getting -10C last week. Yeah, that's I mean, it's anything below freezing is cold. All right. Sorry, Blah, if you've got those ads. I don't know why you got them now. It's Twitch being silly. Let's go ahead and get started. We've been continuing to work on the write a tree object. I think we're really close to getting this done. And then for some reason, one of the previous tests is also failing. So we're gonna have to figure that out too. But until then, let's, also, you know what? We haven't run our tests in a while. I should probably do that. Hold on. I wonder if that's also a problem that we have. It's true. With the new schedule, it does grow more slowly because we're only doing three streams a week. but it's not like you have to stay up super late to watch the stream now you can just be here like part of it. Limanox, hello, how are you doing today? Okay, yeah, now everything's passing, everything's good to go here. So it's really just weird, something I'm doing for the uploaded version is not working. Oh no, what happened? Are you only doing Git client or simple VCS? Like, I have not seen that link. I have no idea what that is. We're only doing Git client for this, and we're using CodeCrafters. So this is CodeCrafters here. It's basically, it's a challenge website and web app. Basically, yeah, so build your own Git client, and then it walks you through all these different things. And by, oh, you suggested CodeCrafters, nice. That link was weird. It didn't look like CodeCrafters. But yeah, so I partnered with them. They gave me a link that I can give out, that if you were to use it, that would, sometimes it's given discounts. So maybe it might be something good to check out. I have a command, CodeCrafters here. So in the past, it's given 40% off. They've not told me when they've done that. They only told me when they did it again. Okay, blah, welcome back. Sorry that you had to go through that. I set the 3-minute ad roll to begin immediately after I started streaming, and then it told me that it did, and then it started you later, which sucks. I'm sorry about that. But now we should be good for an hour, or 55 minutes. So yeah, that's what we got there. Oh, and then for you in YouTube, the link is below in the description. Limonux, you got the new job offer after making a CV for the first time. Congratulations! That's awesome. Everybody getting a job offer right now is really good. All of your previous jobs from referrals. All of my jobs that I've gotten has been from referrals too. I have never gotten a job. Well, I probably shouldn't say that, because after I became a software developer, I've never gotten a software developer job from just applying. My last time that I applied and got the job was like in 2006. And you destroyed their lead code interview. Excellent, good job. That is awesome. Well, regardless if you take it or not, that's good to know. Good to have that. It's such a confidence builder, isn't it? All right. So anyways, yeah, this CodeCrafters basically gives you the ability to go through a bunch of different challenges. Build your own Git is one of them. There's some other challenges here too, like build your own grep, build your own BitTorrent is what John Hu did with Rust. There's the Redis and SQLite and Docker that all look interesting too. And then the 3 main languages that they have are Rust, Go, and Python, with all the other languages sort of in beta. So it's obviously none of them are full. Like some of them you can see like, okay, there's only 13 stages available for Crystal, as opposed to all 77 stages for the primary languages. Your current job offers you stonks. Yeah. I mean, it's one of those things where you always have to make a choice, right? Like it's good to be able to make that choice. It's a very good place to be. Xanax, hello. How are you doing today? Yeah, it's like 5 years worth of promotions for some fields. It's there's an entire thing about promotions and why they can be so why it's so hard to get them. You're in Austria now and you're shopping. Well, awesome to have you on. I suppose you'll be busy shopping as opposed to hanging out with us, but good to see you, and I hope that Austria is good to you. All right, so if I remember correctly, where we left off is that our get cache tree, create tree, something like that, write tree is not working correctly. So if we take a look at this, everything is up to date. If we do a get write tree, it gives us this. And we should be able to sort of take a look at what this is. So that is what is it? It's get is it cat object, cat file, and then I want to look at what this is, and that's what we see here. Now what I would like to do is do the same exact thing and get the same exact name thing as this. So we're going to do a cargo run write tree. We have a bunch of sort of things that are printing out that we don't need to anymore. That would obviously cause problems when we push this up. Also, the hash is different. But if we take this and we do a get cat file, it doesn't see that it's a tree object. So it basically, something in there is causing problems. And if I try to do this with mine, this gets a stream did not contain valid UTF-8. So we have a problem in there somewhere when we're creating it. But we're getting really, really, really close. We did find a way to read these files. Let me see if I can remember what that was. It was it a cat and then a hash, or was it there was something we did. Hold on, let me go, we'll take a look at history. Although I don't have anything in this profile that's bad to look at it, so that's fine. I remember that it's a pretty crazy looking command we're doing. Oh yeah, it's this thing. Oh, we're using printf, that's what it was. So then we want the thing that we're looking at. So in this case, I want, oh, I lost it. So we'll put that onto desktop get. This is going to be get my cargo get. And you are going to be in directory 39 FC. Now it always gives us that problem, but now we can just take a look at that. And I can also do the same thing with the cargo write tree. No, cargo, no, get. Oh, and this was that one. It was 3.7. So you're gonna go into just get.txt. And I want you to be in directory 3788. Okay, so I can now compare those two together. And we can sort of see what's going on with it. We can do okay. Should I helix or should I bat? I could bat it. Let's do cargo get up here. Oh, right, you're binary. How do I look at, how do I, what can cargo get you, I guess? So here's what we got. That didn't really change the size at all. I was really hoping to like push this up, but that didn't really work. Lymanox, you've been using Zillage and you absolutely love it. Yeah, it is really nice, isn't it? Okay, we do. Okay, so we have tree 373100. Okay, that's great. Then there is a null there, and then a mode. Oh no, there's a 644 null, and then we have our space. So get attributes, and then we have the 20 character hash, which is to here, and then another mode. So 10644, and then continued. So get ignore, and then another 20 characters of stuff. And so far, this is looking exactly the same. No, it doesn't. Wait a second. We're missing everything after cargo lock. I don't even see the source here. Let me put it back to... Okay, there we go. That's better. Okay, so we did that. Then you are the same here. I'm using my finger to trace on the screen so I can look at that. So far, everything's looking exactly the same. So we can see that the hash, the SHA sum is correct and exactly the same, even though it's not printing correctly. But that's, you know, that's expected when it's not, you know, valid UTF-8. Okay, so we get all those. This is fine. Now we get to source, and this is where it's different. So source is not the same here that we have here. And so I think that right now, I believe that that's the source of our problems. Do I work with Rust in my day job? So recently, my day job became my weekly job. I'm only working on it one time per week, 1 day per week. I put it all into 1 day. And so what that means that I get to spend a lot more time on Brooks Builds. So technically my day job is now Brooks Builds, which means that, yes, I get to work with Rust in my day job, but obviously it's not like the same definition as what you're talking about. So no, I don't, nobody else pays, nobody besides you all pay me to do Rust. If that makes sense. Okay, so we have this is great. The sources is not working fine. So let's come back into here and figure out what's going on. I have a theory. I realized it last week on Monday. And I put it into Discord. My theory is that when I'm creating the directory and I'm hashing the contents of it, my guess is that I'm supposed to hash it before I put in the header. That's a guess. I don't know for certain that that's what it is. There was some part of me that was like, did I read about that? And I couldn't remember where it was. How come I chose Rust for this channel of business? You sort of had the same vibe check feeling, but haven't seen industry take it up much. We've seen the core industries take it up. So like Microsoft is writing a lot of Rust. They started a rewrite of all their core libraries in Rust. We've seen that Apple and all of what we used to call FANG companies have Rust in some capacity that they're using, but it's all for infrastructure stuff. So like Amazon is using their stuff for a lot of like Lambda stuff behind the scenes. Microsoft is using stuff to like rewrite a bunch of their core libraries for the kernel, essentially. Linux has started bringing in for kernel stuff. Meta has been, putting stuff in there for some of their core things. So it's not being used for like their front ends or for what do I want to say for it? It's not being used for basically things that we interact with on a daily basis, but things that keep their systems running. Basically, systems programming, like what it was originally sort of designed for. And because of that, Rust opportunities are there, but you don't really see them very often because they get filled so fast. Like it's not like you don't, generally speaking, a lot of companies I don't think are going on to like Indeed and saying, hey, we need like a senior Rust engineer. That being said, I am seeing more recruiters on my LinkedIn ask for Rust engineers. The problem is that they're all senior. Like everybody wants senior engineers right now because they don't want juniors touching that core systems level stuff. And we're probably not going to see junior level Rust jobs for a while. That being said, like eventually it's going to be there. It never changes. I know it's one of those things where most companies are willing to hire somebody if they don't have any Rust knowledge whatsoever, if they're senior in something else. Because then by being senior, you're sort of like proving to them that you know how to get to senior. And so they now believe that, okay, if you're senior there, we can teach you the Rust, or we trust that you're going to learn the Rust in order to like do that for us. Oh, is there rustjobs.dev? Let's take a look at that. Oh, that's cool. Okay, yeah. So here's a bunch of Rust jobs. You see, like, it's not like Indeed where there's like thousands and thousands and thousands and thousands of these, but there does seem to be a bunch of these out there. And oh, technical writer. Okay, Let's Get Rusty wants that one. That makes sense. Blockchain, there's a lot of blockchain Rust stuff. They were one of the first industries to sort of adopt Rust wholeheartedly. So not too surprising. And a lot of senior. So here, I'll share this. Thank you, Leminox. You still don't really understand what systems mean in the systems programming way. Oh, your offer from here was from the job from here. It's in Rust. Nice, excellent. Well, that's really fun. Okay, here's my understanding of systems programming, and I shamelessly am stealing this from somebody else. I want to say Tim Clicks, but I am not 100% sure. So that might be fake news. But okay, so here's my understanding, or good. Here's my definition that I've been internalizing. Systems programming is where you're programming things for systems that need to run as fast as possible. That's it. Like the language is attempting to run as fast as possible because it's going to be used at like a very low level systems way. And where do we have that? We have several languages that fit into that category. And pretty much anything that does not have a garbage collector, right? Because a garbage collector is you taking some speed at runtime and saying we're going to sacrifice some speed in order for safety concerns, in order for developer niceties, developer experience, something like that. So immediately C# is out, Go is out, but C++, C, Haskell doesn't have a garbage collector, right? Like a lot of like those languages suddenly become systems languages under that definition. Rust, therefore, is also in that definition too. x86 assembly is the way to go. I mean, in a way, assembly, yes, could also be considered under that definition. That being said, Rust is one of the few languages that can fit in that definition of systems programming, but also has a lot of the niceties that we expect from more modern languages that do have garbage collectors. Like, you have all sorts of abstractions that you can use, but the compiler, and this is one of the reasons the compiler is so slow, the compiler spends a lot of time optimizing that into being as fast as possible. And that's what not the garbage collector, the borrow checker is kind of like a garbage collector in that way, is that it's really making sure that we're not doing anything bad with memory. And that's also like the point of the garbage collector. Make sure that you like, they'll clean up for you, so you don't have to worry about that. Borrow checker just, tells us, no, you can't do that. If you want the control of a systems language, you have to do the right thing with memory. And so it's basically, let's see now. Does that mean that it's you can only write super high performant code in Rust? No, of course not. But just the same that you can write really slow code in C or C++. It just opens the way that you can write super fast code in Rust or C++ or C. Use unsafe more than you should. It's one of those things where if we ever feel that we're not doing something right, then that sounds like there's learning there, right? There's a learning opportunity that we can spend some time researching and figuring out, how do we get around this? And maybe you can't, but maybe you can. And the only way for you to know that is to dive in and learn more. Erlang is used a lot in telcos from what I read. It was made by telcos. Worked for a telco years ago, but you never saw it in use. Oh, so it was probably like really low level type stuff. Also, hello, coffee drinker. How are you doing today? You were doing systems programming in Python at a company. That didn't work great. Yeah, systems programming in Python is a very interesting choice. Ninjatron, hello. How are you doing today? I think that Rust has a lot to nudge you in the right direction. I went to this was years ago. I went to a functional programming meetup, and we were chatting about Rust because a lot of people, like back then, a lot of people were like, Rust is functional. And it's like, well, Rust isn't functional per se. And I was one of the only people that had experience in Rust. It was mostly people talking about like what they had heard of Rust. And so my description, and I still stand by this, is that Rust tricks you into using some functional paradigms and making you think that it's not functional. And I think that that's a great way to get you into functional programming. Is just like, we're gonna use traits. We're gonna use you're gonna use objects, but without inheritance. Well, what do you have to do? We have to, all these other things, and it's fine. Like, we're gonna use iterators, and it's like, that's actually like, these are core functional ideas, but you don't have all of the mathematical stuff behind it. Because at that same meetup, I saw some people in the hallway talking, and it really made me upset. Several people were saying, oh man, I wish that I could do functional programming and get into it, but I can't because I'm not smart enough. These were senior level architects and senior programmers who were programming in lots of different languages, but they literally felt that they were too stupid to write functional programming because the terminology is so steeped in math. And talk about an entire culture accidentally gatekeeping like a bunch of really smart developers out of it. It's sad. You made startup in JavaScript regretting now because it's expensive to run in the process of migrating to Golang. Well, I mean, putting on my my business hat, that's pretty normal, right? Like, so you start with something that just lets you write and iterate really quickly, and then you validate, and now you can switch over while making money to something better, right? Like sometimes that's what we have to do. If we start with Rust, unless we're really fast with Rust already, that or Go or something else, like we may not ever get enough people going before we run out of money. Rust made me love OCaml and Haskell. That's also a fun thing. Is like it lets us do that. It gets us going without realizing that we're going. Yeah, I've grown to like the Rust description of things. How much do you think changing to Golang will help? Oh, you're talking to Liminox. Ninjatron, I have a hard time with that. OCaml has done a lot to make that curve less steep, though. I feel that if we have trouble learning one thing, learn something else and then come back to it. It's just slightly out of our reach right now, but that doesn't mean it won't be out of our reach later. All right, let's continue on. What were we working on? We were trying to figure out. I'm thinking that when I hash the directory itself, that I'm adding in the header for it, and then I'm getting a checksum. And I think that I need to not do that. So here we are in write tree. So we have write tree object. This is our recursive function. So we walk through, we do all that stuff. Dir object. Okay, so if it's a file, it's just hash the object as a file and then go for there. If it's not a file, so it's a directory, write tree object. So we want to go back up here and do that, which then gets us a checksum. And then we do new tree object. Oh, that makes me worried that by going through here, how am I doing this? Okay, so walk builder, we're getting all this stuff. I should be going through and doing it. Oh, AutoMod caught something. What happened here? Let's see, this was... That's fine. Okay. Oh, it thought JIP was, oh, because it's part of the node name. That's weird. Okay, so let's see. So dir object metadata. Okay, so we get our metadata. Now this is from each object, right? And if you're a file object, now I'm coming back here just to write tree object. So I just immediately call out to that and hand it the file path. Of our dir object, okay. Now, if we take a look at you all, that might, well, I have my objects. I'm not necessarily seeing anything that's super wrong with that, or at least jumps out at me as the problem. Groovy, hello. How are you doing today? Apestegua, hello. Sorry about butchering your username. How are you doing today? What are we going to use for the front end? So no front end for this, because this is just building a Git client. So we're not building GitHub, we're building Git itself. So I guess the front end is the client. It's the front end and the back end together. As it were, it's a CLI tool. Now, when we're going into hash object, oh, but then, okay, so wait, and then I object extend, I do that, sort by, I then save to disk, create the file tree. Oh, I extend with this one first. Okay. Okay, so I get you. Then when do I get... when am I getting the hash of it? When I save to disk is when I get the hash of it. Oh, but wait, no. I think that in hash object, I think I get a hash too from this. Ooh, potential problems. Oh, you're wondering if you're going to use something like Crossterm or Ratatouille. I'm not using anything. I'm not actually using anything at all with this. I believe that they gave me access to something for CLI, and then I didn't use it. So it's really just literally looking at the args and then just assuming that they're in the right position and not really like worrying about it. Any tips on how to communicate better and be verbal when you're working on problems? When you solve problems on worker code, you never talk even on stream. I learned by, well, okay. I want to say I first started because when I was a systems administrator working on people's computers, they would often sit in the room, and I found that if I explained what I was doing to them, but more in like terms that made sense to them, it would make them less uncomfortable. Also, if I was unable to fix it at that point in time, then I could, they would feel better about it. It's like, oh, okay, you tried all these different things. And then it's like, okay, let me take it to my lab and do black magic on it. So I sort of like started learning, just sort of chatting about it that way. And I did systems administration for 8 years. So that was a long time of practicing, just chatting in front of clients working on a computer. And then later on I became a teacher, and my specialty was live coding. So exactly what you see here, just explaining to students what's going on line by line by line as I'm writing it. And that really made me good at live coding, essentially. So practice. It's all just practice. Will streaming on Twitch help you? Yes. Like, it can't hurt, right? Like, It is just like if you want to do practice, even if nobody's watching, you can use the little red, like open up your stream in another window, and Twitch will like, oh, somebody's watching you, and there'll be a little one next to next thing. Consciously, you can know that it's just you and nobody else is there, but you will. It's enough to trick your brain into, okay, somebody's in the room with me. It's sort of like having like pair programming with other people. But you don't actually have other people there. And then, of course, if people actually start showing up, now you do have people there. And then there you go. Now, that being said, it just, like, it's all about practice, right? That's really all it is. They're uncomfortable watching you work. Throw them out. Black magic time. It's more of like, ooh, I have no idea what's going on. I need to go and try something. I'm not confident anymore about this. And so I was like, okay, I need to take this to the lab to work on it. And it's really because you don't want, this is more of a business type thing. In front of customers, you don't want to be uncertain of what you're working on. However, in front of your teammates, it's okay to be uncertain. It's just customers. It doesn't help, even if they're internal customers. You don't want them losing faith in your team. Nice, Groovy. Oh, you're working on with. Are you using Rocket for that? I just saw the Rocket. You have a rubber duck that sometimes you use? Oh, I have a rubber duck too. Although I threw it down the hallway for Zilby to fetch at one point in time, and he never brought it back. So it's down there. You heard there's out loud and quiet thinkers. Yes, there is definitely out loud and quiet thinkers. And if you do in pair programming and mobbing, it's important to give time for both to work. That's actually why I like mobbing more than pairing. When you have more than two people together, it actually becomes easier for people to sort of like drop in and out of what their comfort zone is. You identify as someone who thinks out loud. You like to hear, yeah. I have noticed that I am better when I'm thinking out loud than when I'm not. Like sometimes I'm like, man, I suck as a programmer. And then I get on to stream, I'm like, oh, I actually figured this stuff out. Or I'm like pairing with somebody else. I'm like, okay, I'm not quite as bad as I thought I was. It's funny how that works sometimes. You're waiting your microphone. Nice. Well, you could still talk out loud. Nobody can hear you. And both is possible at the same time. Pair programming is what your nightmares are about. Okay, I would recommend figuring out a way to make it at least not be that bad. Okay, so we're trying to figure out, we have some debugging stuff that we're trying to do. So our SHA sum is incorrect for a directory, but it is correct for a file. So I guess what we need to do is figure out maybe what it's supposed to be and look at some of our documentation for what it looks like. So we looked at this beforehand, and I'm not sure how much helpful this was. Because what I want to see is is like a directory inside of that commit object, but I don't actually see the suggestion here for that. Which is unfortunate. We could also look through, it might be time to look through other people's code too. Because I think we looked through this before and I don't think I saw what I was looking for. Yeah, okay. That didn't get us anywhere. Let's, there was something else. Maybe was it reading? there's this, but I don't think this is helpful because it shows us from the user's perspective. This one might be better. Oh, wait. Am I did I? No, I did sort it by alphabetical. Okay, so that, no, I did do that. I did do that. Now, this is our problem right here. We have, like, inside of there, we have the tree, and then this isn't the same thing. Oh, but this is not helpful. Okay, because okay. Okay, so the checksum was not the same in ours, though. Which is why I think that maybe it's something about the header. And I'm thinking that maybe I'm not supposed to put the header in before I go and do it. I missed a bunch of chat. Sorry about that. Let's see. Oh, rock was supposed to be emoji. Okay, it doesn't show up on mine. I don't have any of the emoji extension services or plugins for my browser. Using Angular and Axum for the user-facing front end, the protocol servers implemented Rust and Hyper-Tungstonite communication. Okay, nice. Your computer loves it when you start everything up. That we're supposed to be using computers a lot, right? Work them hard. You want to move it all into a monorepo? Yeah, monorepos can help out a lot. I don't know if anybody answered. Oh yeah. Groovy answered it later. Everything in one repository. I think CJ from Coding Garden just did a video / stream on what a monorepo is. Although I think that was more from a JavaScript sort of point of view, but I don't think it really matters in the end. The most famous monorepos would be the one from Google, because all of their code is a single repo. From what I understand, they don't use Git. They have their own proprietary sort of version control system. It can be really, really, really powerful. They use Mercurial. Okay. Oh, you did an internship there. Nice. Oh yeah, I've heard of Mercurial. I've never used it. I remember hearing that it's faster for bigger projects. Once a company gets to be a certain size, you start needing to do that kind of work a lot more often. I think the problem that a lot of smaller companies run into is trying to do that kind of stuff before you need to. It was one of the worst experiences ever. I have heard so many different like things on it. Like some people are like, this is the best thing ever, and some people think that it's like the worst thing. It's so interesting that like and it just makes sense, right? Like of course it's going to be different people feel differently about it. It feels like a cult from the outside. I mean, they are a really large company. And they have a lot of young people working there. That also won't help. Okay, so okay, wait. A get tree begins with a header of a string space that after null. So the SHA-1 hash, but how would I know to put the, well, I guess I could get the SHA hash. Oh, wait. Did I compress it first and then I get the hash? I get the SHA. Okay, no, I get the SHA from the content. Okay, so file. We get the header from the file. Oh wait, no. Hash object is just reading it from. Oh, weird. Wait a second. I don't think hash object is doing what I think it's doing. This is reading it from something that's already been written out. It's literally reading it from the file system. And I want to. No, but wait, that's fine, right? That is right. I want it to read the file from the file system and then hash it. Okay. No, so that is okay. But when it's a directory, I'm going back into write tree object. Can I put in? Okay, so if there's a file object here, so, okay, can I do a debug of the name and checksum? Checksum. Oh wait, isn't there a 2 hex or something? Encode hex. Okay. Oh, type annotations needed. I thought you turned it into a string. Can I do that? Okay, maybe. Okay, so let's cargo run right tree again. And so, okay, so here's all these that we're getting. And I want to look for when we do source. We never do source because, oh no, wait, source here, rain tree object source. No, we don't. Okay, hold on. So here we get the checksum here. Okay, so I actually want to do this here. And this should show me dot, I think, and also source. Okay, so source, so dot source, name source is this. So I want to, okay, I want to take a look at what this is here. So we do our print. This will be B282. Okay, so we have tree, block cat file rs, and then hash object in it. Okay, so it has the things inside of it that looks relatively correct. Okay, then hue I want to do get ls tree Ooh, I don't remember which one this is. Oh, maybe not name only, so I can see the hashes. Yeah, there we go. Okay, so then source year here, so that would be 5.3. Now when I did yeah, see, you're different, right? This was B2 and you are 5.3. So then I want do our print. This is gonna be get source source. Okay, this is 5.3 B1. Okay, so up here we have source, and we're gonna do our cat get source. All right, so there, let's take a look at what the difference here is. So cat file, these so far are exactly the same. So hash object, rs. Yeah, look at that. These are all the same. So the content of each file is exactly the same. Okay, that's good. Wait, why is... Uh-oh. Uh-oh. My mouse just died. Oh, and we just got an advertisement break. Let's see, do you still work? No, okay, the mouse is recharging, so I'll have to use my my trackpad over here. Actually, I have this one. Give me a second and I'll get myself set up again. Oh, how do I get it to find a new device like this? Okay, well, maybe I can't use this trackpad. Okay, fine. I don't have another mouse up here, so I'm gonna have to use just the trackpad on my my laptop. I saw the red light on the mouse last night. I'm like, I should charge that, and then I forgot to. So that's fun. Okay, so anyways, ad break is almost over. I missed a bunch of chat, so let's take a look at what's going on there. I don't think one person project should be a monorepo. I don't see any point. So I use a monorepo for my infrastructure as code, and that's it. That's the only one I do that for. Everything else so far has been not monorepo. Basically, I've my recent thoughts on this is that just like microservices aren't like the answer to everything, but like big gigantic like projects that like just for everything aren't the answer for everything either. It's somewhere between, like sometimes multiple projects in one repo and sometimes not, but not every bit of code that like I ever write. Twisted Seed, hello, how are you doing today? There are special tools to set up monorepos. Yes, absolutely. And some of them depend on the language. I didn't watch what CJ used in his most recent video, so I would recommend taking a look at that. There was a dev that we hosted at the Node.js meetup way back in the day when I ran that, and she used Lerna. Which is JavaScript based monorepos. So I've heard good things about this. I've never used it myself though. And I love the icon. Their logo is great. I don't know if they can handle multiple languages for Lerna. There probably are systems that can, but I don't know what they are. I haven't looked at them. But I kind of want to use this just because of the logo. Like, you want to make a monorepo of your personal projects and generate docs and stuff using Mixtrail. So yeah, I mean, there shouldn't be a reason that you can't do stuff like that. Oh, blah. You requested pet the cat. We can do that. Sylvie. Yeah, you're awake. Yeah, so multiple language monorepo, that's, I have no idea. Oh, and Liminox, you also, we'll do these together. Oh, Groovy, I'm sorry about that. As soon as I'm finished, I'll take a look at what that link was. We should get a thing to allow like Zilby to do a trick, and then we can give him a treat. But I don't have a trick for him to do right now. But thank you for both that. I'm sure Zilby was happy with that. Oh, okay, so that was Basil dot, okay. Basil dot build. Multi-language, multi-platform projects. Is this for monorepos or is it for like also cross repo? But that's pretty cool. Oh, it's sort of like a build system. Build, deploy, all sorts of fun stuff. Cool. All right. Now this was mine. This goes to main and then continues on and misses utils and write trees. This was the get one. And you're getting everything else. So you're failing at this point in time right here. So before, okay, so I want to see. Now we printed out, okay, let's do the printout of the names again. And I just want to see what the name is. And what I'm looking for is utils. Okay, so there is a utils here. Okay, let's also throw in the hash. Okay, so then we see utils has this there. Now, can I read what utils is? Oh, and okay, let's also check to see if we do a get ls tree and we look at you. And then I want to get ls tree this one. So then we have all of you in here. That's fine. They're all blobs. That makes sense. And I want to see, okay, so for example, cat file is the 1F. Cat file is 1F, 0, 0. Hash object is 1713. Init is 22E0. Lib is 28. C4. LS tree is 6974. Main is 7923. Utils is 3C. D3. Okay, so all of these are coming in correctly. That's all making sense. Right tree is DB4F. Oh. Oh. I wonder if this is the problem. Okay, so if I do my command, and then we do a git right tree again, and we do a git ls tree. I would love to see the blob. Okay, but I don't have the one for source here, do I? Okay, so now are you the same? That was utils last time. 3C D3. Okay, no, right tree was the one that was different. Right tree is 1891. Okay, now it's fine. So that's okay, but it doesn't solve the problem. Kubernetes microservices for a personal repo. Oh no, every time. Kubernetes has sort of become has the same joke level that what regex has, where it's like, oh, we had, we didn't have enough problems, so we added Kubernetes to add some, infinite level of problems. We've solved more things too, but like, yeah, now it's fun things. It sort of feels like Kubernetes has sort of like fallen into that level of joke. Okay, so why is the contents of this tree different? Okay, so for all of these, I should be able to cat them the same, right? I think that it's just the source. But the source hex is valid too. So there's something going weird with when I read the source. Okay, hold on. So here's okay, so here's our source. Same source, we have you. And so if I try to read you, this fails, right? So if I want not a tree object, hash mismatch, it got written out. Can we actually go and take a look at the file and see what the difference is there? So we're going to go into get objects v2. And this was b2 7f. Everything looks normal there and the same there. If we look at file 7f zlib compressed, okay, so if we do file for everything, it's all zlib compressed data, so that makes sense. We can use our print trick here. And the problem is that we get that invalid compressed data CRC error no matter what. Let's see. Bahadawa, hello. How are you doing today? Let's see. How is a tree hash supposed to be computed anyways? From my understanding, and this is where maybe yes or maybe no, I am creating a file that has a list of the files in it, all the objects in there, along with a header of what they are. So like, you know, tree or blob, and then also the size of them, no, the mode, the size, and then the hash. And for some reason, the files are fine and the directory is not. And that's the concern. Now, when I'm done with this, I get this checksum back out, and the checksum, the contents seem to be okay, kind of, maybe, it's hard to tell. I can't open it up though, so the checksum maybe is, it is the right file, as in it does exist. And if we open this up now, so this was source.txt, so here's that file that I just that we just wrote out, and it's the one from ours. So we have tree, and then okay, then it's size, so 300, and then the mode. And so when we looked at this last time, this is what we got from Git as opposed to ours. Let's see, cat file rs. Then we have all this. This is exactly the same. Oh, wait, this is different. So this is the same all through here. ls tree, rsig. For main then you go to utils is the same. Right tree, and you're different. but maybe you're different because you might be different because I have to make sure that you're committed before I run the right tree. Otherwise, it's going to be different. So if I do a, do the get one first, right? So get right tree, and then we'll print get source. And this is 3, 1. Oh. Get objects 3, 1. Okay, we still have that compressed data from when they did it correctly. Lymanox, thank you so much for stopping by and saying hi. And have a good night. Pigsy. Yeah, I don't think I have Pigsy. I don't have that. I might be able to install that. Let me see if I update brew, and then let me see if I can install Pigsy. And then if that works, that will give us better information, maybe. Okay, so if I do brew search for Pigsy. Okay, it found that. So git push, no. Ruin. It is a, oh, it's from zlib. Okay, cool. That seems appropriate. Let's see. Personal, let's see. Other shell. There, that makes it. Okay, so if we do that, now I want to do a Pigsy, and now I have that. So we want to do a Pigsy, DZC, the object files. Let's do a get right again. So I want a Pigsy, DCC. Our object file is in get objects 311f. And we'll pass this to a hex dump. Okay, this is what we've got. And then I want to do the exact same thing for the other one. So let's see. When I wrote mine, okay, no, that's get. Okay, cargo right tree gives me 4E64. So we're gonna do a Pigsy. E64. Okay, so we want to check to see if these are exactly the same or not. So our first line here, tree. Okay, so that makes sense. Get attributes was fine. I think the problem was in source. Oh, but I don't know where the source is going to be in here. How do I read this to, I'm not sure how I'm supposed to figure out where the issue is using this though. I'm not used to reading the hex of stuff, so I don't really have a good method for doing that. I mean, so we have a get ignore. We have a cargo lock, cargo toml. Oh, you don't need the hex dump. Try without the hex dump. Okay, let's try that without the hex dump. Okay, that's exactly what we had before, essentially. So if we do that one, it allows me to compare at least all of these. The characters that were printable, are they exactly the same? And they are up until we get to source here. Right? Yeah. So it's telling me the same thing. It's just a little bit easier to look through. Is the contents of source is wrong. Okay, so now I want to let's see. We want to get I want to get ls tree or 4e and then that. Oh, that was mine. Okay. So that's mine, and then yours must be this one. (311F). Okay, so then this is the get source. The get source. So if we take a look at this, and is there a man get? Is there a way for me to go one level only? Show only the named tree entry itself, not its children. So maybe D. And if I go for the first one, 6.4, not a tree object, right? Okay. So the problem is, oh, it's okay. So I'm telling it not to recurse into source. So I wonder if the parent here, there's something about it that's wrong. Which is unfortunately still not helpful. Can I ignore directories? Okay, so there's these. So that's a tree, and then I want your blob. Okay, so then we get all of you coming in here like that. If we just check in, let's say, what's a small one? The main should be fairly small. I should be able to do a get ls tree, no, ls cat file. Oh, and then a -p. Ooh, not a valid object name. Okay. So that's a problem. Oh, wait, did I do this wrong? That should be right, right? And if I do a get do our Pigsy 7955F. Yeah, okay. So that is correctly opening this up. We have blob size null, and then it just starts with it. And I don't know about the end there. Oh, I added OD at the end? Oh, okay. There we go. I don't. So that's been happening recently. I don't know what's going on. I don't know if that's Zellage that's happening, or Alacrity, or something else that's like causing me to add in those weird characters. I don't know what the OD is for, or like I don't know if that's hex that's somehow being dropped in when I'm doing some command. If I do up arrow, it doesn't do the same thing. So I don't know what is with that. But thank you for that. Okay, let's say the director structure is my prod source main rs. I understand the object for source will look like blob, size of main rs, SHA-1 of main rs, but what does the entry of source in the main? Okay, yeah, so this is what it looks like. Is like it's the actual compressed file itself. And this is openable by the Git one. So it thinks that it's correct. So my system is right. Which is more evidence that whatever I'm doing with the folder, with a directory, is wrong. So this checksum is incorrect, but then the contents of that still seem to be fine. Yeah, that's blob file. My question is about the entry of source in the object file. Okay, yeah, so let's find that. So when I do here is source tree. Okay, so you are that for E. So then we're going to do our... Now, I can't open this. When I try to open this with Git, it says that it's incorrect. So we have to use Pigsy. What was that? It was DZC. and we open up, it is 4e d1. And so we have tree space size, and then the null character I believe goes in there, and then we're straight into the thing. And if we do the same thing here, so if I do a get okay, so I want to do a okay, so this is the get one. This is 308C. So you're going to be a Pigsy 308C. Let's not do up. Let's do down. Oh, of course you just lost that. Cool. And then I want you to do the same thing. Do Pigsy DCC. Okay, and then we're gonna do a get. Nope, not a get. A cargo run. We're gonna go to source here. Wait, I just did the entire thing again. That's not helpful. I actually want. Sure. Well, 4e d1. So 4e d1. Okay, there's mine. You're not helpful yet until I actually go in. We're gonna do a get ls tree of this one. And then we're gonna get, this is 202C. Okay, so two zero two C. Okay, so comparing them, and then okay, we can do tree sync. Oh, but that doesn't really take me around. Okay, never mind. Oh, stop. Don't lock. Okay. Yeah, so here we go. We're comparing the source tree. So tree, so 300 size 10064. Okay, so the sizes, the mode is the same. Cat file, 2 new lines just got thrown in there because, you know, of the hash is binary. 10064 hash object rs. Okay. This is all the same. Okay, so if the content of the file is the same, then if the checksum is different, but the content is the same, the only thing that I can think of is that I'm supposed to get the checksum before I put in the header. That's the only thing I can imagine. Can I oh, let's see. So you're the Git one and you're mine? I forgot which one was mine now. Okay, so if I saw some if I saw some of you, okay, we got 7-3. Okay, so that's not the same, Shaw. To get objects, this is 4E. No, they are different. Okay, so wait, the contents of the file are different. They look the same here, but they're different. So something in the binary is not the same, even though whatever's printed out looks the same. That's where the hex dump becomes useful. Okay, let's try it with the hex dump. So we're gonna do Pixie. Which one was this? Okay, that one you pipe to. What? Okay, hold on. You're that one, right? No, you're the wrong one. I wanted 4E. Pipe to, what was it? This was SHA-SUM or hex dump -C. Okay. I want to do the exact same thing. So you're 20 to hex dump. But how do I know? How am I going to be able to tell what's different? Okay, so let's, can I pipe this to bat? Let's see, so that's great and all, but that's not helpful. I want to pipe this to Helix maybe? Yeah, okay. So now I can just go through this with this. So I guess like here's the question is like when I do find the difference, what is that? How do I use that? I guess I've never used hexdump before, so I'm unfamiliar with what this output really is trying to tell me. RO Cloud, hello. How are you doing today? It looks the same. Yeah, it does look the same. I'm just going through it really quickly to make sure there's nothing like one character off that I'm missing. Look at the last rows. Sure. Let's go down. I mean, that looks all the same to me. All throughout. The SHA sum, though, is different. Oh, is it because it's... I was under the impression that when I compress something, that it gives me the same SHA sum. Sorry, if I compress two files of the exact same content, that I would get the exact same compressed binary, right? So then if I SHA sum the compressed files, they should be the same, right? But maybe they're not. Even if the content is the same, then it's going to be different. But the hashes of the uncompressed files, that I print out, yes. Yeah. So the hash that I'm getting here, the checksum, is of the uncompressed files before I save them to disk. I'm compressing them and putting them out there and then writing the hash out, and that's fine. Yeah. I was trying to checksum the compressed file to see if maybe that would provide more information, but okay. So write tree object isn't working if it's a directory itself. So what's happening here? If I do, but then this part is. So this part of our if statement is working. So this is working correctly. So I can remove you. This not working so well. The checksum is different. Okay, you understand you're giving the name of the uncompressed hash for the blob file, but the hash of the compressed file for the tree files. Oh, wait, is that right? Is that what it is? Hold on. Okay, so write tree object. I get, okay, so the checksum is when I return this. So that's the hash when I save the disk. When I save the disk, I get, okay, so it's already compressed. It's already compressed. Tree file. Okay, so what if I just let me just try something here. If I get the hash equals I don't know if any of these are right. Get hash SHA-1 hash update hasher. Okay, yeah, that looks right. So get hash, hand it in the tree file. We don't, let's imagine that I just don't care about, I save you to disk. It's It's gonna be the wrong. Oh, it's gonna be the wrong. Okay. So there's gonna be some things here. Don't let me forget that this is, I'm not gonna be able to read it because the name of the file and where it stores it are gonna be different. But I just want to see if the contents are like the actual hash is now gonna be the same. So if we git commit trying to hash before compress. Okay, so I want to, we're gonna do a git write tree first. And that gets us that. And then I can also now do a cargo run write tree. There, okay, so those are different there still. And then I can see tree became A87B, and so I want to now take you and do a git ls tree u A87B. Ooh, okay. Well, would you look at that? That is correct. So, okay, that's a good sign. Okay. Yeah, always hash raw. Yeah. That, I mean, of course, it makes sense. I just apparently didn't notice that I was doing that. Like my brain didn't see the difference in it. Fix save to disk. Yeah. Well, the problem is I'm providing save to disk. Now, wait a second. I create the tree file. Create the tree file. Objects, iterers. We're just throwing this in there, extending it. Okay, that's not compressed. I'm getting the hash of it here. When I save to disk. Oh, right. I then compress. The first thing I do is compress it. So what I want to do is actually get the hash before I compress it here. So we move you up here. Instead of compress, this becomes content like that. Now I can compress you, and then we can throw you in there like that. Okay, so then I want... Okay, hash equals that, and return you. So then... fixed save. Okay, so when I write tree, we failed at permission denied. We failed at permission denied. What am I, okay, so I'm attempting to write, oh, but that's writing to this. Okay. Writing tree object. That was the tree object, I believe, right? We're just writing file to Gummin. This is in save to disk. Okay. It's not necessarily helpful. I am pushing up our error. We get a permission denied. What I want to check to see is if the file already exists, then we're good to go. Alonso, hello. How are you doing today? Is this too complicated, but it's great? Well, thank you. It is decently complicated, but I don't think it's that hard or that, I don't think it's too complicated. I think it's just complicated. Yeah, I think it means that file already exists because it tries to go there, and I'm really curious. So if I do an LA our dot get, I have write permission. Do I have overwrite permission? I don't think I have overwrite permission in Mac OS as far as Rust is concerned. I think that's something else that exists. Okay. So is it you who had the error? We have a couple places where we do a standard fs right? Right? We have here and we have here. Oh, and here's where we have in hash object with save the file to exist. I unwrap, which is going to cause a problem if it already exists, but oh, see, I'm trying to check to see if, okay, maybe that's what I need to do here. Okay, if the directory exists, so if this path already exists, so if you exist, then here, let's just do a print line. But we can return the hash. And now that works. Okay, so, all right. So that works because I haven't committed it yet. So whenever I commit behind the scenes, Git is doing a write tree. It's not waiting until I do write tree behind the scenes. The way that this entire thing works is they do a write tree for me when I commit. So this worked and printed out without that error here because the file doesn't exist yet. But as soon as I do get write tree, no, I have to first get commit. Now if I do this again, path already exists, skipping, and let's do a get write tree. It is a different hash here. Okay, so it's a different hash. Oh, a break just started. I think we're gonna take a quick break because I want to go grab a quick drink. And we've been here for like 2 hours or so. Get write tree writes the current index. Doesn't it write the hash of the tree that just got created? I think that's what we noticed. Yeah, get write tree what you get added. Oh, is that all of it is? Are you sure? I don't know if that's true. Anyways, I will be right back because we have an ad break here. So let me go ahead and switch to Big Cat 3-minute break. I will be right back. All right, I am back. You're sure that get rate tree will give you the hash of the tree for the current index? Okay, well we can take a look at that. So let's jump back into main here. My old mouse is still charging. Okay. Okay, so now if okay, so I've done the local commits, right? So there's nothing to be uncommitted here. So the write tree should write everything, right? Now if I do a get first of all, ls tree of just you. We see these, okay? So if I do get ls tree of the one I did, which is you. Ooh, look at that. Okay. Okay, look at so the one I wrote out actually is now readable by Git. It's no longer telling me that it's an invalid file. So that's excellent. Now can we see a difference in here? So 1773 6B 0A 9E FA C0 97 FD 92. Okay, all the hashes, all the checksums are exactly the same. Okay, okay. Where was that? Okay, so the modes. We have 0644 and 0755. Where? Oh, this last one. Oh, your get sh. Oh, okay. I was wondering about that. Okay, so if we take a look at the mode here, so 644 for everything. We have 5 6 no read write, so was it 4 4 2, yeah, so that's 644 644 644, so that's all of these. For the directory source, that is 655, but you're just whatever 4,000, that's fine. And then you are the mode, you are the correct mode for that. Okay, so I do need to grab the modes from this. I kind of like just cheated with the modes previously, but yeah. Okay, so what do I want to do? Where am I getting the mode from? So we get the tree object there. We have our tree parser. Yeah, see, here's where I'm just cheating, and I'm making all the blobs 644, and I shouldn't be. Now we know we need to set this to be what the mode really is. Now, this is getting the mode out. For you, can I go to references? Okay, so I create a new tree object type is file. Oh, and I just get object type. Okay, so hold on. Tree object is file. Do I get the path ever? I do have the file path. Okay, I do have the file path. So if I get the file path, can I do something like... Uh-oh. I don't think I can do it. Yeah, there's three types: normal, executable, and symlinks. Yeah, you don't want the exact modes. Okay, only oh, right. Okay, so I just want to check to see if it's executable. But I can't tell if it's executable or not here. Okay, so if we create a new function here, is executable. I guess like in this one we can have it be the node, but let's start with is executable. So you're going to take in a path, which is going to be a path buff, and we're going to return a boolean. Okay, so we're going to start with, do I need to actually load the file up to get to find out if it's executable, to like figure out if that's on there? Like, what can I get on here? Can I get... None of these look like I can get executable bits on them. Oh, wait, metadata? I can get if it's a symlink. I can get, oh, permissions. Turns the permissions of the file this metadata is for. Permissions. Read only. Private fields, great, okay. Oh no. Let's see. Oh, Cloud. I don't remember if I said hi to you already today. Hello. How are you doing today? Maybe only a header. Also, Hugh Brown, you posted a link. Oh, yeah. Okay, so this is from a Reddit post. Okay. I did say before. One of the projects I want to bake is something that allows me to like see the first time that somebody says hello in chat or says something in chat as like a personal hello cue. All the hello cues that I've seen before only track if somebody says hello, not like the first time they say anything at all. That's kind of what I want to build. So that way I can see it. Sorry, Zilby, I kicked my heater. Let's take a look at this Reddit post. Okay, so you get file permissions mode. But really, I want executable. Now I do have the metadata. Oh, but wait, am I looking for not read only to see if it not okay? Now they're basically saying that there's a trait, the permissions ext, that I can pull in. Oh, is executable. Ooh, that's even better. Don't see. Oh, that's actually a crate. Okay, that's not part of standards. Ooh, but I don't. Do I want to bring this in? Is there an execute file? Okay. Well, that's cool. We don't have this, but I could just add it in, and we can just use this. Oh, we could just look at how it's done too. Yeah, that's true. All right, let's go into your docs. So functions. Wait. That's a trait. Is executable. Okay, so path as ref is execute. Wait, what? Well, that's if okay, it's a Windows. I only have to care about Linux. Or Unix, I guess. Is file and permissions.mode, and that is not equals to 0. Okay. That being said, though they're implementing is executable for the path. That's what it is. That's what's going on. Pramjit, hello. How are you doing today? Is this the first episode with this project? No, the first episode is live actually. And there's even a cut version of the first episode, which cuts out all the parts where I talk to Twitch chat, like right now. And that's all in live. If you look at my channel and you look for the one that has the nice, pretty logos, as opposed to just the, clearly just a clip from the live stream, then it should find it. It's the one that's get in it. And then also I have a playlist for Git too. I haven't cut them all down yet though. Okay, so really, and permissions dot. I just need to see what the heck is going on with the permissions. So before we do any of that nonsense, let's come back to here because I do have the metadata. I do have metadata right here. So, okay, if you are a file, we're previously printing those two down. Let's do a new print line. I want to debug what is the metadata. I just want to see what do we have in there. And let's now run. So we have this mode, but that's not the right mode. There's a bunch of stuff on here, but we do have these permissions. Okay, so oh, and this is the directory only. I did this in the wrong one. I want you up here. So let's do metadata dot. So we have permissions. Okay, so if I do permissions, read only. That's it. Okay, so I want read only. And then let's also get the name. Okay, so I want everything is false, 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 false. Your get.sh is false though, so I can't use that to determine whether or not it's read write. Okay, yeah, so let's go back here and we'll take a look. The permissions X trait in standard. Okay. Oh, right. You mentioned we can pull that in. Where is that? Okay, so this is going to be standard OS Unix. Standard OS Unix prelude. And then we can get the mode from it, which is a number. So I have to then turn that into like a string and then check the last bit. Okay, so we have to pull in, this is standard OS Unix FS. Prelude, permission extended. Let's go find, okay, so here's our metadata. Here's our permissions. So we can get the mode now. So here your get sh is 261 test is 188 as opposed to 261. Everything else is 188. Oh, and cargo toml is 152. That's interesting. Yeah, okay, you're right. It's probably printed octal. Oh, how do I do that again? I don't remember anymore how to do that. This is just a U32 as... Yeah, okay, so hold on, but how do I do that in debug? I don't think I can, right? Oh, you're playing music? Using yeah, it's a lot of fun when you start figuring out how to do all that kind of stuff. It's pretty cool. Do I have to just do this in format? I can't remember the rules for this. I think we have to do format. So we'll do this is going to be a octal like that. Okay. Ha. Okay. That didn't work the way I expected it to. Let's just we'll change it to print line, so we have U as the mode. And then we'll put in our name. Okay, there we go. So what I want to do is check to see. We have 755. Now cargo toml is 600, but I think as you were mentioning, it doesn't care. It's either going to be 644, 755, or like the 1000 or 4000 or whatever it was. I think that's what it is. Oh, it did it at the end of the line? Oh, it did. Okay. Right, I keep on forgetting it prints out like exactly what I put in here. Okay, so it did do the thing. This is a little bit easier to read though. Okay, so how do I want to deal with this? I probably want to pass in the mode. Okay, so I want to convert this to the correct type of mode. So when we create our hash tree object, we're going to get the mode and pass that in here. So that's case name. Okay, if your file where do I create the tree objects here? Right there. Okay, so instead of taking a mode in like a string, let's take this as a U32. Actually, wait, no. You can still be stored as a string. Here we have to pass in the node as a U32. And then instead of getting object type of mode, we want to just check to see and grab it out here. If a file is not executable by user but is by group others, do you set the mode to 644 or 755 and get? if the owner can execute, then 755, else 644, I'd say. Trying to find official sources for this behavior, but the man page. Yeah, I've noticed that the documentation for like the internals of Git are kind of not great. Okay, so I'm thinking that we get the last 4 pieces. So that's what? 1, 2, 3. Well, the size of this is always the same, right? Does Git actually mess with the permissions? Yeah. So I think what we're finding out is Git is lossy on permissions. So here's what we found so far. Let's do our git ls tree gives us this. And we see that it thinks that cargo toml here is a 644. If we take a look at cargo toml, it is a 600. So Git clearly is seeing, Git only allows certain types of modes in there, but it does know about 755. So it knows about, wait, this is mine. There it goes. Okay. It knows about 755, and it knows about 644, and it knows about 04D1000. It knows about that. And I think that's it. I think that's all it knows about. Arzio, well, have a great rest of your day, and thank you very much. So the answer is it's kind of messing with the permissions, but only in very specific cases. So if it's executable, it is this one, 755. If it's not executable and a file, it's 644. And if it's a folder or a directory, it's this. That's it. So now looking back at this, okay, so hold on, let's tree object type new. Okay, so what if I do this? We then pass in the mode into here. Okay, so now I wonder if I should write the mode in here as you. So you're going to be a I don't care about space. We're just going to throw these as strings. Okay, so if you're a self tree, we know that your mode is going to be this. My mind branked out on the Y that I need to do. Oops. And let's also, oh, you know what? We can make this a static stir. Okay, got it? Okay, so now if you're a blob, we need to figure out what the mode is going to be, because it's going to be one of 2 things, right? It does make everything usable, readable. Yeah, it does. Which makes sense, because if you're putting it up onto the internet, or I guess I know, because Git is not always put into the internet, but Git needs to read it. So that makes sense. Oh, wait, did you find documentation, Albert? Okay, so this is Git. Okay, so from Git on GitHub. Where is it? Okay, we got mode. Wait, did I? Oh, here. Okay. Permissions. Mode. Interesting. Yeah, so it's literally saying 755 or 644. And that's it. Interesting. Okay. I wonder if they have anything in here talking about that. I like the reason. Yeah, so it's going to be 755 or 644 every single time. And so all we have to check for is the now we get the mode, so we can get the mode from this mode is a U32, and we get it, and it actually shows us like 1000. And so I want to see if it ends in 644. Oh, and we actually print this out, didn't we? Cool. I broke it because I saved it. I think I have a run through up here. Yeah. Okay, so we have, it's either going to be you know what I should check for is just this 100755. If we check for that, everything else, okay, and we also see everything is the same size here. If I look for, let's see, 0, 1, 2, 3 to the end. Okay, so let's go 3 to the end. Okay, so if we have mode for that, let's convert mode into a string. So mode equals mode to string. And then I want to let the bits for the mode equals, can I do mode I want a slice of it, right? To the end. And then, okay, so that's a stir, and that should hold the end. Then I want to, what are you upset about? Mismatch types. Did I lose the mode? No, okay, so it's just other things causing it. I can do the exact same check, mode and 0. Oh, because it's octal 0, 100. That's what the O is, isn't it? Oh yeah, let's try that. So here, their check is mode and that. Okay, so mode and 100 octal. Oh, I thought that was an O, not a 0, 100. Oh, and C, any number that starts with a 0 is octal. Okay. Interesting. And I think, okay, so we want this to be just the octal number coming in. So here, let's start this over again. Let our mode equals if mode if mode is set essentially, and the octal, okay, an octal, so is it O 100? It's not and. What's and in this? That's checking the bytes, right? It's checking the bits. Oh, this is checking to see if that bit is set in the 4 binary bits. Okay, that's what it is. So if that's true, so okay, so if mode and that, then I want our mode to be, you're going to be a static stir, right? So I want you to be 100. Are you 755? Yeah, you're 755. Otherwise, you're going to be 100644. Okay, and then you're very unhappy. Mismatch types expected a Boolean found at U32. I was really hoping that this would give me a Boolean out. Oh, 2 things. Cannot find value 0. Oh, so this is not how to do it either. Okay, so mode. Oh, okay. So okay, is equal to, there we go. Okay, that gives us that. Or it's not equal. So we're gonna find out. If we have exactly the wrong logic, then we'll just reverse the if statement here, and then you become the mode. Okay. Now this mode returns self.1, and I wonder if it's going to be okay with us doing this, because what I would love to do is something like this. Self dot 0 to owned, but no field. Okay, fine. Hold on. So if you're blob, we have our mode, and I want to return the mode. And actually, it's all of them, isn't it? Could I do something like this, where just like, I don't think I can. I think it would be very upset of me if I did that. Okay, fine. Self-blob, we get that. Return the mode. Self tree mode. Turn the mode. Okay. Why are you upset? Expect a string found a stir. Right, I'm returning, okay, stir to owned. Oh, it's a double reference. Do I have to really do to owned? I could clone it. Does that work? Expect a string, found a stir, expected, okay, no. Oh, to string, that's probably better. There we go. That's much better than to own twice. Albert, you got hit by a link. What happened? Oh, it's code. I'm sorry. Yeah, to string. We got it. Okay, so we got you, and we have some errors now, but that's okay. So this returns what the mode is. Now what are you? This function. Okay, so when we add in the mode here, we need to get that permissions mode, right? Okay. And okay, it is going to be correct. So metadata permissions mode. So metadata permissions mode. And I want actually, let's go all the way. Let's actually just do this here because we need it on both sides, right? So let our mode okay. So then we hand you in there like that. Display. Why are you upset now? Oh, right. Okay, so you, we don't actually care about you. Okay. No more errors, no more. Okay, so we have some warnings, but no errors. Okay, no errors, no warnings. So if I now run write tree, excellent. Okay, so let's do a git commit. This is setting mode correctly. Okay, so that's good there. We're gonna do a git write tree, and we can do a git ls tree of 5cb3. And that gets us, okay, so this is the git one. So this is the one from git. Hold on, we're not sure yet. This is the git one. Now I want to do a cargo run write tree. And now I want to do a git ls tree. So it is 5cb. Okay, so it's the same hash. It's the same hash. 5cb ce 5cb39. There we go. Everything is looking good. The same hashes. Okay. Sorry, I think I was really loud there. Sorry about that. All right, we should push this up. I think one of my previous codes was not passing, so unfortunately we're going to have to probably fix that before we know if this one actually runs. So let's find out. As long as you don't mess up the git files. Yeah, the same hashes. I did notice that right away. But hey, we're good. We're good to go. Okay, build successful. So now it should start running the tests. And if I remember correctly, one of the tests is failing. And I think it's for like ls tree or cat file or something like that. Which is unfortunate because that means we have to go figure out when I changed it for this one, I must have broken it, but none of my tests are failing. Yeah, there we go. Stage 3. Do I see what stage 3 is? Stage is read a tree object. No. Yeah, hold on. No, read tree object is 4. Create a blob object is 3. Oh, that's what it is. Okay. Create a blob object is not working. And we're panicking on not found, no such file or directory on hash object line 15. Okay, so on hash object line 15, we attempt to read this path. Oh, interesting. Why is that failing there? Okay, so it's trying to hash object -w monkey. Oh, is it because of this -w? So I have my right flag. So in main, in hash object, okay, so we get okay, so we're making sure that okay, we're checking to see whether or not the -w is in here. Okay, path buff new. So we create a new path of where we are right now. When I join this, what is it? Does it update this? It does not update this. So I want to do something like this. Okay. Stage 3 still had a failure, but now we're failing on a different part. So your program we created, okay, so my program is that expected standard out to contain that. We got that, okay. So I need to turn this into proper. Oh, the check is okay. The checksum is a vec of u8, and then I want to hex and code this as hex. And then I want this to be a string. Let's see if that makes it happier. Thing is, you're skipping writes on file already exists, which means there could still be issue with the compression file that you don't catch. I mean, yeah, it's true. Okay, good. So we got to stage 5, which is where I think we are at. And we're printing. We have a bunch of these printing things happening, which I need to now get rid of. So, right. So we want to. Are we finding? Do we have any debugs? We don't have any debugs. We have a bunch of print lines though. So, if the directory exists, so I don't want you to already have. I don't want that in there. Initialized. Okay, so we want that. In main, the checksum printing that out is good. In right tree, I don't want this. Okay, so initialized get. Denise, hello. How are you doing today? Also, sorry if I butchered your username. Okay, so you're good. You're good. Okay, so in right tree, okay, so we get the checksum from right tree. That's fine. In ls tree, file names for each print line file name in ls tree. I think this is fine. Okay, what else? Writing tree object. Okay, so okay, no, so we don't have that anymore. Yeah, so we okay. I think I'm good again. So removed print lines. Don't want. Let's try this again. You're fine. I did not butcher that. Nice. Actually, I'm one of the main YouTube accounts for watching, used by the same person that goes by the name of Albert. Oh, nice. Well, hello on YouTube. Okay, so next things. Found get object written. Okay, so it reunit file found get object file does not match official Git implementation diff after zlib decompression. Oh no! What happened? Okay, so there's a diff after the decompression. It didn't match. There's our problem. So we have a tree. Thank you. Okay, so let's make sure we didn't do anything weird with this. So we're gonna do a get right tree. I get we'll do a cargo run right tree. We'll do a get ls tree. Okay, so they're the same hashes here. What did you do? Okay, you did your get sh right tree. Okay, let's double check that. Your get right tree. Okay, that took a shocking amount of time, but okay, that is the same. Those are the same hashes. That's a good sign. Okay, so we have the expected and then the actual bytes wise, right? So the expected, we had tree 100 and we got tree 131. Oh, yeah. Actual. Oh, dot get. Wait a second. Oh. That's it. we brought in a tool to help us ignore the .git folder. And I don't think that it's working correctly. Yash, hello. How are you doing today? So we updated and added this ignore crate, and it doesn't like that apparently, because I think it is ignoring it. Or wait a second, do they not have a, they don't have a .git ignore. They don't have a .git ignore. Okay. Oh, ad break just started. Okay. I didn't even notice that was happening. All right. Sorry everybody for getting ads. Do you know Git internals, or are you just using a resource for reinventing Git? Yeah, so we are using Code Crafters for this. So Code Crafters is basically, it's a challenge website, and it's walking us through everything that we need to do for it. So it's we don't really like know the Git internals, but it tells us, okay, here's what you've done. Now you want to do this, and like these things happen, and here's some information that you can go to sort of like figure what it is. So it's a combination of telling us what to do sort of like in very general, and then most of it is the tests. They have tests for us that tell us whether or not we're doing it correct. Well, I had music running and it stopped for some reason. Why did that happen? Yeah, I was playing something called Winter Solstice and it just stopped. Let's try this again. There we go. You love reading the Pro Git book? I own the Pro Git book, and then I don't think I actually read it. I think I actually own that on ebook and a physical print copy. And I have no idea where the physical print copy is. Oh, it also goes into the internals. Yeah, I never read the book. Like I own it. I bought it at one point in time that I just never actually did anything with it. So maybe that'll be fun to read through at some point in time. Now that we've gone through this. The Git SEM book is a Pro Git book. I don't know. Yes, that is indeed. That is the Pro Git book. Oh, and you could just download it for free. Okay. I'm fairly certain I bought this book. I don't know why. Because I could just get it for free here. And I think you can just read it online here too. Okay, so I'm pretty sure that this ignore is not working correctly. Oh, you know why it's not? You know why it's not working correctly? Because they didn't create a dot. No, they don't have it. There's a .git ignore. The .git ignore gets added in. Huh. It's kind of working correctly. Because in Right Tree, we're using this walk builder. So hidden, yeah, so like shows hidden, show hidden false. Ignoring hidden files. Okay, so we're trying to ignore the hidden files, which means .git. I'm skipping one. Why was I skipping one? I don't remember why I was skipping one anymore. Oh, it's because that's self. It's skipping the first thing, which is itself. Adds a custom ignore file name. So what if I just cheat and we just say we're gonna ignore .get. Okay, so reading file, get objects F7. File, okay, found the file there. Get object file doesn't match. Okay. Now this one, yeah, look, it still has .get. Wait, what is that? Is that .get .c? Or is that part of the hash? That may, yeah. Okay, so we have tree. You can see the null byte index and the hex. Oh, these are the null byte, right? So 74, 72. So this is part of the tree, right? So what is it, like TREE space and then 1 and then 3. So it's supposed to be 100. I get a larger size because I have this .get. So here's the .get. So here's the first null, which is right after the 131. Okay. And then we have 34. Okay. Then we go through here and then we have our second null. So this is the .get null. And then wait, do I want to count this? It's like, what is it? TREE space 131 null. Is the dot the null? A dot a null in the ASCII on the right? Oh, they have 40000. Okay, so these are all zeros. And then okay, we have a space. Dot GIT null. Okay, yeah, a null is considered a dot here. Got it. Good to know. Okay, all non-printable characters are represented as dot. Okay, good to know. Okay, so that's good. So it is just .get. Now, why are you still Okay, that didn't work. So let's come down here. I just want to drop you if you're okay, so if you're not a file, then you're just .get. So if our name is equal to .get, I just want to continue. Hey, all the tests passed. Okay. So this wasn't great. I completely and totally cheated with the .get. I attempted to use that. I don't know why .git was being found. I don't understand that. Because in my .git ignore, oh, I don't have a .git, but we have the ignore hidden. Oh, but is that only that's weird. So I wonder if it's a difference between a Linux system and a Mac system doing that. Ched, hello. How are you doing today? It's been a while. Okay, so we're done. We finally got through this one. All right, so excellent. And okay, so we're completed, which means we only have 2 of these left. The next one is going to be create a commit. Let's see, Albert, you tried for the last 10 hours to crack the password for the latest C23 draft while it's available on a Wayback Machine the whole time. I'm assuming that's not going very well for you, right? Okay, so that's good. We have 2 of these left to go. Okay, so what do we got here? So let's move on to the last Git object we'll be dealing with in this challenge, the commit. You got the PDF, but not the zip archive password. Interesting. I've never done any password breaking. And while I can't recommend that anybody does that because there's obviously lots of issues with me recommending that, for anybody who has to do it for reasons of you losing your own password or anything else like that, it's certainly probably like a good skill set to like sort of play around with for if you need to break into your own things. Okay, let's move on to the last Git object we'll be dealing with in this challenge, the commit. And you have a reference to the git sem commit. To create a commit, you'll need the following information: the committer author's name plus email, the timestamp, the tree SHA, the parent commit SHA, if any. In this stage, you'll implement git commit tree. So a plumbing command that creates a commit. Your program will be invoked like this. Okay, so they'll run your git sh commit tree SHA. Okay, so they're gonna do a write tree, and then we hand it the tree SHA -p. So we have to look into commit tree what this is doing. Commit SHA, and then message. You'll receive exactly 1 parent commit and exactly 1 line in the message. You're free to hardcode any valid name email for the author committer fields. Okay, so we just create any valid. So we can just use Mailinator for this. Your program must create a commit object and print its 40-character SHA to standard out. To verify your changes, the tester will read the commit object from the Git directory. It'll use the git show command to do this. Okay. I don't know if learning all these other commands like git show and git like hash file is really interesting. All right, so I want to do let's look through these. We have our commit objects. If you've done all of the above, you now have 3 trees that represent the different snapshots of your project that you want to track. But the earlier problem remains. You must remember all 3 SHA-1 values in order to recall the snapshots. You also don't have any information about who saved the snapshots when they were saved, or why they were saved. This is the basic information that the commit object stores for you. To create a commit object, you call commit tree and specify a single tree SHA-1 and which commit objects, if any, directly preceded it. Wait, was the other thing M? Was that what it was? And I was just like, oh, so we're gonna have tree SHA. P is the commit SHA. Oh, interesting. Okay. So if we do, oh, this takes in the message as standard in. Interesting. Start with the first tree you wrote. No, you'll get a different hash value because of different creation time and author data. Right, so every time you do this, it'll be different. Now you can look at your new commit object with getcat file. Interesting, okay. The format for a commit object is simple. It specifies the top level tree for the snapshot of the project. At that point, the parent commits, if any, the commit, okay. Now, if we go take a look at this, this is the commit tree command, and that is what we are implementing here, commit tree. Creates a new commit object based on the provided tree object and emits the new object, the new commit object ID and send it out. Okay, so then interesting. Having more than one parent makes the commit a merge between several lines in history. That's interesting. That's how it tracks merges between commits. Okay, so we have a parent, we have a message. And then, okay, so we have the tree. Interesting, okay. So if we were to do, like, we have no changes in here right now. So if I wanted to make an update, so let's say oh, we already have a, okay, so we're gonna do, I did not need to exit out. I keep on doing that by accident. Okay. We created another little line at the end with the README. I don't know why I didn't see. The README is right there. It's just in yellow. For some reason, my brain completely ignored the yellow and looked only at the white, blue, and red. That's interesting. The way my brain was sort of like parsing through the colors there. I wonder if it's because it was exactly the same as this, and therefore my eyes were like, oh, that's the same as that, and just ignored it. Okay, so I want to do a git commit tree. No, so hold on. We need to do this separately, right? So in order to create a tree of that, I now need to do a get add that's added. Now I can do a get write tree. That gives me that. Then I want to do a get commit tree. We give it the one parent, so dash p. Is that right? No, the tree is that. Okay, hold on. Oh, it's the parent is a single commit SHA. Oh, it's like the previous commit that we had, right? What is it? Git log. So it would be this one, right? So we do git commit tree. Okay, so one parent. Oh, so we have our tree SHA. Okay, so you're actually going to be doing it. Okay, similar to this. So we have. Interesting that the order is different for these two. I wonder why that is. I wonder if they're trying to say that, like, the order doesn't really matter. Let me try it in the order that they're going to give me. So we have the tree SHA first and then the commit. Okay. So that's the previous commit. The tree SHA is you. And then we're going to have our dash M message. So, and then our message is simply, does this work? Manual through Git. Okay. And if we look at our log, that doesn't show up in logs here. Okay. But we get this. So now can I do a git ls git cat file? No. Oh, it's supposed to kit cat file -p, right? There it goes. Okay, cool. So that's what we're trying to create, is that. And if we go and look at objects here, so cd to git, or really we can do not showing in log because head is not pointed at commit. Oh, you're probably right. Because it's technically in the future as, oh, because like when I normally do a git, it then also updates my head. So I have to check out that commit. .git, and I want to go to objects. So 4b, F6. Yeah, okay, so it creates that. So it puts it into objects, which makes sense. And then if I want to do our, what was it? It's pigs. That's what it was. your 4B F6. Yeah, so what we expected, this starts with commit. So our header is commit space size null, and then tree. Parent, and then the rest of the author. Okay. So hold on. When we look at that, that's... Now, I don't think we have the tree, right? It starts with parent? No, it does. Okay, so when I cat file this, we have the tree here. On a new line. Interesting. So we have the tree. So not showing is commit size. That's it. Commit size null. And that is not a new line. Oh, so ls tree is writing it with new lines for us. Okay, good to know. Okay, so, oh yeah, P does pretty print. I keep on forgetting that P is for pretty print. So it is making it look nice for us. I don't believe we are pretty printing that. Can I cat file that? So can I do a cargo run cat file pretty print? I want you. Yes, okay, so that oh, ours is actually doing the same thing too. I just forgot that we implemented pretty print exactly the way that they did it. Okay, so I feel like this shouldn't be that hard for us to do. Let's jump into it. Now this is commit file. Nope, not that. I wanted to go here like this. This is commit dash tree. Okay, there's a few things that we need to get out of here. So first we need to get, this is the tree, right? So we have the tree. So two, let's just clone it. Actually, I don't need to clone it, do I? Just make this that. That'll be fine. Okay, so we have our tree. And then we assume that you're a P. So we assume that you're now going to be the parent. So if args of 3 is not equal to dash P, we want to panic missing parent option argument. Okay, and then we're gonna do to make this a little bit nicer. What if we do something like this? All right, let our parent, it's gonna equal to if args of 3 is equal to p. Okay, so in this case, I want to return args of 4. Okay. You can't assume dash p first commit doesn't have a parent. Well, in a normal one, absolutely, you'd be right. In this case, your program will be invoked like this, so that we know that they're always getting us a dash p. You'll receive exactly one parent commit and exactly one line in the message. So this is where it's like, okay, this is the I am matching what they're giving me, which is maybe not like it's not real worldy, if that makes sense. But it passes the test. Like if I was doing a real worldy, I would use the actual proper CLI handling tools to sort of like, okay, give me a dash p, give me all that stuff. If it's not dash, if that's not passed in, it's the first commit. Otherwise, yeah. Okay, and then we'll get the dash m for message. So this is gonna be 5. If that's equals dash m, we return args of 6. Else we're gonna panic. Missing message. Okay, so we have you. So I should be able to, I guess we'll just debug you for right now. We have our tree, we have our parent, and we have our message. So I should be able to do a cargo run, commit tree, bunch of like a tree, a parent, and a message. Okay, so we grab those out. Excellent. Okay, so I need to add in a file for commit tree. Which is actually going to be under library. Okay. So we know we're going to take in the tree, which is going to be a stir, the parent, which we know is going to be a stir, and then a message, which we know is a stir. And we're going to return something, probably a result of some kind. We're going to use the anyhow result. It's probably going to be a string of some kind. So let's to do this. All right. So if we go back to you, we can run you. So we'll do let our, this is going to be the hash of, okay, so let the hash equals commit tree. Okay, so we have our tree, parent, message. And then we're just going to do a simple print line of the hash. Okay. Because that's, I forgot apparently how to do print line. That's what I want to do. Okay, so there we go with that. It's not what I want to do. I want to come back to, do I want to come back here? No. I'm gonna come back to here. All right, so we're calling this, and whatever we're printing back is fine. So what do we want to do? We want to, let's see. It's going to create a new file. It's going to create a commit file. It's going to add the header to that. So we're going to create the commit file. We're going to add a header. We're going to get checksum. We're going to compress it. We're going to save it. And then we're going to return it. We're going to return the hash. That seems to be what we need, right? I think so. All right, so create the commit file. So we're gonna start with just a bunch of blank empty. Just basically just gonna be an empty vector, right? So we have our commit file, and this is really gonna be commit bytes. Is you're going to be an empty vector, and we know you're going to be a vec of U8, and that's going to be fine. We're going to get to you in a little bit. If you have enough money to spend, you should be able to subscribe to someone. You'd be the first one. You do, however. Oh, please, yeah, don't subscribe if you don't have the money. They're just having you be here and like be part of it, be part of the community is more than enough. I don't ever want anybody to like subscribe or like pay money if they can't afford it. I do see that a lot on Twitch and like other things, like, oh yeah, just like go ahead, it's not that much, which I don't know, it feels skeevy. I want people to succeed in life. I want you all to like. I want you to get to the point where you can, where you get all the money you need. Which usually means graduating from college or school, whatever school you're in, and then getting a job. That's usually what I want you all to be able to do. Okay, so we have our commit bytes. So that's our create commit file. That done. Now. Commit header. I know you need that. We'll figure that out. Now the header is going to be that plus the size, right? So that's going to suck. So our header is going to be equal to us like the string, which is, so we're going to format this. You're going to be commit space and then size of some kind and then a null. So we know that you exist. That means we need a size, and then right now that's just going to be 0 because you're starting with 0. And then oh, you know what? It's going to be the commit bytes length. So it's going to be commit bytes length, like that. Now, of course, you don't have any, so that's fine. So now to add the header onto this, we're going to then, I want to prepend. So we're going to do a commit bytes I guess like we want the end result, right? So there's extend, which adds at the beginning. This adds it to the end, right? Yeah, I want to do the opposite. I want to add it to beginning. I don't think that has something like that. Oh, wait, we could do the opposite. What if I then do our as bytes okay, so this is the commit. Okay, so this is the commit body equals that, and this is going to be the full commit plus the header. And then I want to now do commit as bytes into vector to vec. I now want to extend the commit body. Okay. You're now the commit body dot length. Okay, so there we go. That's good. Yeah, this will be fine. I'll just like get the commit body and then I extend the commit with the commit body. I think that works. Okay, so there we go with that. So now we've added the header. We have to get the checksum from this now. So, which we already have. So with the get hash, right? So letter hash equals get hash with a reference to the commit. And there, okay, so now we have the hash as evacuate. Okay, so now at that point we can return this, so we know that you're going to be an okay with the hash what was it that I need to get that? You know, I don't think it was any of those things, right? Wasn't the permissions extended? It's not. I don't think it's any of those. In main, we're doing the, let's see, right tree. Oh, I'm just doing hex encode with that. Okay, fine. We'll just do hex. I thought there was a encode hex that we can grab in here. So like the hash dot and oh, there it is. Encode hex. So there we go. All right. Slowly bringing it together. Roshan, hey, amazing content. You follow the channel. Well, thank you very much. I'm glad that the content is helpful. There is into bytes on a string that directly gets you a see, what was I doing wrong? There's as bytes to vector. Let's try that one. So this is into, you're right. One way to do it. Much better. Thank you for that, Albert. Okay, so we got you. Okay, so we got our hash now. We compress it. So let the compressed the compressed commit is now going to be okay. We compress you, we hand you the content. That's going to be our commit. Okay. Okay, so now we have our compressed commit. Now, at some point in time, we have to create and insert something. So in here, we have to put the commit into the body. It's kind of something that we need to do at some point in time. Because right now, there's an empty commit. It's not really helpful. Although I think that Rusty could have optimized the same. Oh, wait. You're like writing your comment across both systems. Yeah, well, I mean, I'm pretty sure that in the end, because like Rust, the Rust compiler is trying to be as fast as possible, it has that thing where it calls it zero cost abstractions. It's like, yeah, if I do a bunch of stuff that's unnecessary, if in the end it can become the same thing, the compiler will make it the same thing. And one of the reasons why the compiler is so much slower compared to many other languages, because it's doing all that stuff for us. Although the compiler is getting faster and faster with every update, which is really nice. Okay, so we have hashed. Okay, so we have our compressed commit. We need to save the file. So is there a save? Save to disk, which takes in the compressed. Okay, so we have our compressed commit. And then we return the hash. So here, let's organize it that way. So the last thing that we need to do is just throw these things in, throw the actual content into the compressed body. Now, if I run this right now, this should have a commit space 0 null in it and then nothing else. So I kind of want to test that. So this is going to be our commit body. So we want to do a cargo run commit tree. There, that should get written out to file. So I should be able to do a, what was it? Is the pig? Nope. What did I do? There. This went into DC F5. Uh-oh, that did not go there. EE. No, that's not right. Did this not actually write out? It did not. Okay. Okay, so actually, now when I save the disk, wait a second. Save the disk. Oh, compresses it here. I don't need to compress it myself. Okay, so, all right, hold on. We don't need the hash there at all. Do let our hash is equal to save the disk, and then this is the commit. Like that. That's what I wanted to do. So I hashed the compressed ones. That's obviously a problem. Okay, so let's cargo run this again. And I want to do a nope. Oh, I don't need the helix right now. That's what I was doing. Okay. And then you are going to be the DC. F5. There we go. Yes. Okay. So that's exactly what we have. We have this commit 0, null, and that's it. So that's exactly what we wanted to see. Okay. So good to know. Now, we put in then inside of you. Did you show this behind the scenes? Don't remember if it does. One of these things it kind of did, right? Commit objects. Yes. Okay. So once we have that header, then we're going to have tree, space, and then the tree. Okay. So then we want to, okay, put the commit into the body. So we want to add in the tree into here now. So that's going to be our commit body. We're going to extend. And it's going to be format. The tree, what was it? It was the name tree, space, the hash, and then is there a null at the end of this? I don't remember. We looked at that beforehand. Okay, so here is TREE space 300 null, and then no, wait, this is not a commit. This is the wrong one. Oh, you know what? I don't think I looked at the object correctly. So let's do, can I go back until I find, those are called cargo runs. Oh, git commit tree. Oh, so you're this F3 3F. F3 3F. Uh-oh. That didn't work. Cat. Okay, so this is 4B F6. Okay, yeah, so commit. So COMMIT space 1, 2, 3 null TREE space the commit, which should be 20 of these, right? So what is it? TREE space so it's 8, 16, 4, and then that immediately goes into the next thing, 31, and then parent. Okay, so it's there's no nulls in here whatsoever. That's interesting. Okay, that's good to know. All right, so we just have tree like that, and we pass the tree, and then that's it, nothing else. So then I want to into bytes that, and then we're extending that. Are you okay with that? You are okay with that. Excellent. Okay, so we have our tree that we're adding in. Okay, so that's the first one, right? Now the second thing that we throw in here is the parent. So parent goes in next. We have parent. And that's going to be the parent like that. Why are you upset? Oh, because I can't extend it multiple times. Got it. Okay. There you go. So we extend. Now we have the parent. I mean, there are some things that are more important than others, right? Like domain names, especially if they're useful to us in the future or now, especially for business purposes or something else. Like I can see that those are much more valuable to spend money on. Like giving me money is like, yeah, sure, that's really nice and I appreciate it, and it's like it's very welcome. But if you have something that's like really important to spend on, then domains to me like is that probably comes higher in a priority. The way I see that. And like courses that I can create would be important too, which is one of the reasons why I'm creating courses and doing all this stuff is like hopefully then there's value that you can get in exchange for money. I don't want it to always be one way. Okay. You think you spent less than 70 euro to get your domain name for 9 years? That's really good. Okay, so we have a parent. Next is we have author. And so we can lie about this. So we have our commit, body, we extend, I'm gonna format. Okay, so this looks like author. So we have author, and then we can just make something up. So this is gonna be Brooks. What's the way that they show that it looks like? It's author. What's that timestamp? Oh yeah, it includes like an actual timestamp. Author Brooks, and then we'll just say Brooks at melanator.com. We do need a timestamp, don't we? But we have access to time. So in here, right? Isn't there a time thing? Request bytes. Oh, for some reason I thought they were giving us a time library. But they did not. Okay, well that's fine. So I need to get like the timestamp, and then we'll just do minus 700 because I think that's what. Oh, 0700 is I think the that's the GMZ time zone. GMT. Okay, so if we do that, now we need the timestamp in here. Now, it's not a duration. I need like I need the now. I need like some time. There's a time module instant. Is there like an instant now? System time? Maybe that? We could do system time. Now. Okay, you give me a system time, and then you're upset because why? System. Oh, a couple of reasons. So first, you need to be into bytes to do that. And then timestamp. Oh, ad break. Perfect. I need to take a really quick break, and I'm gonna go grab a snack because man, it's 1:30 already. Oh man. Okay. Yeah, I don't really care if it's real time or not. It just has to be a proximity of real time. All right, we're gonna do a really quick break. Nope, wrong break. I wanted cat break. And then I will be right back, and we'll continue working on this, and hopefully it should be good. So I will be back in a minute or three. Oh no. How long ago did Zilby jump off? Let's see. Zilby jump off his desk and is now on on my chair. Oh, I'm sorry. On my chair. Just now? Okay, perfect. Okay, Zilby. Well, if you want to hang on the chair, you can. But it's going to be loud. This is technically a standing desk, so let me put it into standing position. Everything's okay, Zilby. Yeah, see? It's not scary at all. And I have a little standing thing for myself. There we go. Okay. He's behind me. I don't have a good camera position for him. If I roll him around too much, he won't be happy. So anyway, no cat for a second. Oh, that's fun. There we go. Now we're good. All right, let's see. Yeah, we do see the top of the green screen. Yeah, you do see there. It doesn't go quite up to the ceiling. So when we're in standing mode, I have to like have the camera pointing down a little bit. Let's see. Crazy Frog, hello. How are you doing today? How do I not want to blow my head off when trying to use async rest? I think, I mean, there's several different types of async rest, right? There's doing async with like creating all of the threads yourself manually. There is using async await with something like Tokio, and there is using async await, or yeah, I guess async await with anything that's not Tokio. I would recommend staying with Tokio. That has like the most support in like the most documentation right now of everything that I've seen. And after that, ironically, having the same mental model as promises in JavaScript is probably the next easiest thing to deal with, which is not helpful for most people if you don't know JavaScript. But it's as long as you stick to trying to remember of like how that works, like how the JavaScript sort of mental model works with async code, it kind of just is exactly the same. Yeah, no, I mean, it's not great with promises in JavaScript, but the idea of you using like async await with that, where like, okay, my code is actually being wrapped in something that's running asynchronously, but the next line of code won't finish until it's going, but other code can sort of like go through and is simultaneously running, and it's all in this like weird event loop that's happening behind the scenes. That kind of just like, if you just take that mental model and like lay it on top of Rust with async await, it kind of just works. And it's shocking how well that works. Okay, so let's okay, so timestamp. You don't implement display. Now I'm curious. You do implement debug mode. Okay, so let's find out what exactly you are that you write down. So let's do Brooks, not real address. So if I do a cargo run, we commit tree for that. And then we want to do a cargo cat file. For you. Oh, it was cargo run. Okay, so tree. Oh, let's do a get. Tree size. Huh. Oh, it put in, oh, yeah. Okay. Oh, we have TV sec. TV nsec. Huh. Which one do I want to use? Let's see. Oh, what did I miss? Theodore Ellen, hello. How are you doing today? You're trying to inject stuff there. So chat doesn't run on my, I don't have a bot running all chat on my system. I would like ask that you don't just spam though, because that makes it so that other people's chat is less easy to read. And I would hope that Nightbot doesn't just run this. Also, I run Mac OS, not Windows. That's true. I do have Windows and Mac OS. I could be running chat on both. I'm not running chat at this time, although I do have other things happening. You're doing good. How about you? Yeah, I'm doing pretty good. It's a good Monday here. We're getting really decent progress on this project, which is also good. All right, thank you. I guess like it's more of like the fake hacking spam, mostly because that could just take up a lot of lines. The every once in a while though is fine and funny. Okay, so what did I do wrong here? Obviously system time. Now I don't really care about the time. So what if I just get this TV sec? Can I just get that and use that? Let's see, timestamp. So I want the timestamp. Ooh, duration since. No, I don't want the elapsed. Return the amount of time from an earlier point of time. This function may fail. Okay, no, that I don't think that's helpful. I want like now in, I think it's the epoch. Can I get the TV sec? Is that? Okay, we're gonna go take a look at the documentation. Oh, it's not docs, it's like doc. Oh, right. Yeah. If it starts with if it's docs dot, then it's the crates documentations. If it's doc dot, it's the Rust documentation. I keep on forgetting that that's how you can sort of like see which one's which. All right. So we want in the module time. Oh, wait, constants. Unix. An anchor in time which can be used to create new system time instances or learn about where time. Okay, so. This constant is defined to be, okay, 1970. Okay, that's good to know. So then, oh, okay. So hold on. So system time duration sense. That's what it is. Okay, so our timestamp system time dot now duration sense, and this is called Unix epoch. Okay, that gives me a duration, and then I want, you don't have implement display, so I want, ooh, how do I, oh, as millis. I think that's what I want. Okay, much better. So tree, that doesn't seem right. I miss something weird here is happening. But then we have you. Okay, so that's good. So we have our tree. Author. And then, okay, then committer. I don't think I'm supposed to have new lines. But maybe I am. Maybe I'm supposed to have new lines. I could swear we looked at the one we put in there. I didn't see a new line in there, but maybe I am. Let's see. C finally has type inference? Wait, really? Doesn't C barely have types anyways? Oh, try with the Pigsy command? Yeah, let's try that. Right, I need an actual commit. If I do get cat file, yes, let's take a look at. Okay, so I did the git commit tree, and so that gave me. Then I think we looked at this, right? No, then we did -p with this. Okay, yes, this was a real commit. See, this one has the new lines there showing up. And if we use a this was 4B. Oh, yeah. So this was the one. I literally just push an up arrow. Okay, 4B F6. Okay, that's exactly what I want to see. So we have this commit. So COMMIT space 255 space null byte, and then our TREE space, and then we have the hash. So 8, 16, 20. And then we have our PR, like PA parent. Where's the space in here? There should be a 20, right? So, okay, here's the space between parent and then the next hash. And so I'm, oh, byte 038. Where is 038? Is that a new line? So it'd be after tree, right before parent. So this one, right? So we have, here's a space. So D N E R E A P. Oh, is this it? 0A is a new line? Oh, I didn't realize that. Okay, so, all right, so then we're supposed to put new line in here. So we put, okay, tree, parent, new line. New line. Okay, so we do that. Then let's go ahead and try this again. Cargo. We commit true with that. We do a git C5F1. Okay, so tree, our size. This is really, okay, this is wrong. Something's going wrong with my header. What's going on with this? Then we have our parent, okay. So tree. So it's literally tree. No, header. So we start with commit space size, and then our size is our commit body dot length. Oh, wait. I'm not starting with commit. Oh, wait. Commit's not there. Oh. Yeah, look at that. I'm starting with commit size 0. Oh, that's weird. Oh, delete. Right, it's delete. I keep on forgetting that's deleted by cat file. Okay, never mind. So then, okay, so you're right. That's probably fine. That's probably working just fine. So tree. Oh, well, in that case, this actually is fine because that's the hash that I have. I am missing the new line here. There you go. Tree, that, parent, tree, that, oh, there is no parent. For some reason, I thought we put parent in there. Yeah, okay, wait, this is the first one. Is there another one? No, that's just how to run it. Hold on. Okay, let's do our git our commit tree of that one again. So I want to do a git cat file C871. Okay, so the okay, wait, oh, ambiguous. So we have C71 CD. Okay, it does have parent in here. Okay, so we do have parent, and then that, and then we have author timestamp -700 committer. Okay, then committer, and I want this in there. So if I just take you. And do bytes. Okay, we do this. Okay, so we're gonna have committer. This is gonna be let's actually make this book server here. So Brooks. Okay, not real email address. And then I want the same timestamp, I believe. So we want that. Which then, if I'm doing this twice here, let's just do timestamp as millis straight from here. So then we just do timestamp. Timestamp. Okay. We have a space, -700, new line. Okay. We're good to go there. So now we've added in the committer. Let's see. Yes, man. Hello. Will I open source this project? Yes. I keep on forgetting to put this code onto GitHub because I'm just directly doing it off of Codecrafters. I wouldn't like I don't have any like sort of teaching stuff in here, but yeah, I'll let me just write in what to do for that because I keep on forgetting to. So let's export code crafters git code to GitHub. There is a way to do that. So code crafters here has a publish to GitHub. So you can publish your code to GitHub. It just needs access to my GitHub. I need to like install something to like make it work. So I want to do it like their official way for that. So that's I'll eventually, yeah, we'll eventually get to that. Rug Matt, hello. How are you doing today? Yes, we're gonna put real values in there. Absolutely, we're gonna put real values in there. Let's see. I should probably do that now. So let's go ahead because now we know what a tree. We have the tree, we have the parent and all that stuff. We're good to go. Okay, so first of all, let's see, we get that. Oh, and then we have the message too. We have the committer. Okay, new line, a new line, and then the message. So I want to, after you, we have new line, then another new line, and then the message. So commit body, we're going to extend the message into bytes. As bytes? Okay. So we go with that, and then okay, that should be it, right? Then I need to do this with actual real stuff. So we want to do okay, so for the tree, first of all, get status. Let's get, I can write the tree right now and everything should just be fine, right? So we want to do get a cargo run write tree, and that gives me this. So we're going to do a, oh, and then I also need to get the most recent git commit hash. That's going to be interesting. So I want to do a cargo git log to get, this is the most recent hash. So we're going to do a cargo run commit tree. So, okay, for our parent, we're going to use you. And for our tree, we're going to use you. And for our message, we're going to say, hello from the chat. Okay, and that gives you there. And so now if I do a git, I could just use cargo run cat file p, and then we hand in this entire thing. There we go. So we have our tree. 10 bad, is that what it's supposed to have? Yeah, that was actually what it was. Oh, fun. Parent, author, committer, hello from Twitch chat. Okay, that looks right. Okay, so the question is, okay, now when I run this, okay, yeah, that did the thing. So hold on, what am I looking for? You're free to hard code anything. Program must create to verify your changes. The test will read the commit object directly from the Git directory. It'll use the git show command. Do this. Oh, they're going to use the git show command. All right, git show. What is that? Git show. Do I just give it the hash? This? Git show you? Ooh, okay. Commit that. Author. There. Hello. Git diff. Okay, okay. Hey, that's not bad. It looks like a real commit. So let's go ahead and submit this and see if it works. We're gonna do a, let's see. Ooh, okay, so hold on. It's very upset with all this stuff. So I'm gonna create a new commit. I'm gonna use the normal method to do the git commit. So git add everything. We're gonna commit this with working. And we're gonna push you, and we're gonna see whether or not we get to pass this first try. Oh, I do have warnings there. That's not great. Okay, expected Humpty Monkey, Doobie Monkey, Horsey Monkey, new line as commit message got Humpty Monkey, Doobie Monkey, Horsey Monkey. Oh, it wanted this new line. I missed the new line. Okay, that's the only thing. We can get rid of some of the new messages too. So here we have a message as bytes. So I need to format you. Let's see, do into byte. We have our message, new line. Okay, so then we work with that. Let's also get rid of some of these unused imports. Okay. Let's see, added new line to message. We're going to push that up and we're going to see if this works. Try to. There we go. Excellent. Okay, so, well, that was pretty fast. And that's it. We are past stage 6. We have now created a commit successfully. All right, last one. Thank you, Albert. I know, like after Write Tree took us like 3 weeks worth of time to get through, and then create a commit just took like a couple hours at most. Clone a repository. Oh, now try to check out your commit. Yeah, we could try that. We could try that. So here, let's do our checkout. That commit that we did, and it puts us back in time because we had created it software. If I had I do have a whiteboard over there, but I don't have a camera pointing at it. I could like try to draw out where this is going because it's weird. So, I don't want to, like, we're now back in time and we've now successfully checked out that commit. But I want to go back to the head. Oh, how do I do get switch? Oh, under this operation, is it just dash? Yeah, okay, this brings me back to the main branch. The trees are the same, but it because it's a different commit that's not the same marked as head, it's like weird. Try creating a branch with that commit and then looking at the log. Yeah, sure. We can, well, actually, I could just go back, right? You just check out this and then get log. So this is that one we created. Which isn't, like, we tried it first try, so we didn't really have another one that we created from it. I mean, I could create a branch off of here. So branch test. Let's do a checkout. Oh, a get switch. C test. Get log. Like, it's not really anything different. But yeah, you can see here's that not real address that we created for this. So it's good to go. All right, so let's get switch back to master. Let's make sure that we're on the latest. Let's get branch delete test. Yes, I know I didn't do anything crazy. Okay, so we're good to go there. You didn't know that we were in year, oh, did it? Is that what year it put us in? Yeah, my time is probably not correct, but I don't really care about that. Waleed, hello. How are you doing today? Let's see. What a coincidence! You were watching a video on YouTube. I search event patterns in Rust. Went to Twitch, and you recommended to me. Nice. Excellent. That's good to hear. Also, hopefully those are all helpful. All right, let's take a look at the very last one here. Oh, thank you for that. I certainly will do my best. Clone a repository. So the very last challenge for this. Stage to the challenge, I guess. This is the last stage of the challenge and probably the hardest. We'll see. We'll see if it's harder than, well, than we made write a tree object for ourselves. Maybe it'll be just the same level of difficulty. Maybe it will be harder. Okay. In this stage, you'll clone a public repository from GitHub. To do this, you'll use Git Smart HTTP Transfer Protocol. So you can use the request crate to make HTTP requests. We've included it in the cargo toml file. Okay, that takes us to crates. We've used request quite a bit, so I don't think I need to look into that too much. But who knows? Maybe we'll need to do some special stuff with it. Your program will be invoked like this. Okay, so we'll clone, pass it a URI, and then some directory that we want to clone into. So we don't want to clone it into our directory here. We want to clone it somewhere else. Your program must create some directory and clone the given repository into it. To verify your changes, the tester will do the following. Check the contents of a file, read commit object attributes from the Git directory. To know about the protocol format, check out, okay, then a bunch of these things. So and these articles, okay. Ooh, and then, okay, so several different comments from, now this has the most comments compared to all the other challenge stages had basically no comments whatsoever. So yeah, this showing is probably going to be significantly harder. But all right, let's see what we can do. So first off, we've used git clone before. Like we've done it. Now, do you tell us what you're cloning? Is there actually a blah blah repo? No, there is not. Do I have, we have some repos that we can use. Let's see, what do I want to grab? We have, what's like small and easy to do? My ZSH config, so like the config ones, they just have 1.5 because they just have these in there. Oh, and this is executable. So that might be good too. We can start with this and sort of like play around with it. I'm sure that they have another one that we can use as well. So I'll start with this one. So this is where, okay, so if I do code, local, HTTPS, that's going to be, now you're doing a .git. Are you going to hand me a .git? No. Oh, interesting. They just say blah. I would assume that they're going to give me a .git. This is HTTP protocol. Yeah, I wonder if they're going to, well, we're going to find out when we run the tests, and it's going to yell at us for like what it's trying to do. I'm actually really curious what they are going to try to set up for us. So let's go ahead and handle this, create a file for it, or won't do the thing. Actually, we can create the directory. We can do that part. And then I want to see what they're running the test as, because I'm guessing that we want to just be really slow and just do exactly what they're asking for us. And I don't want to write too much code and then find out that I'm on the wrong path. So we know that this is going to happen. So we would know, okay, so clone is the next thing. Okay, so if we have clone, then the next thing is going to be the URL. So args of 2. Yeah, so it's like clone is 1, the URL is 2. And then the directory that it's going to go into is 3. Okay, and then I need to create I think I can name a file that. I think that will be fine. Yeah, this should be fine. Everything will be fine. Okay, so we have used, so we want the URI is going to be a stir for right now. And then we're going to have the target dir is going to be a stir. We're going to turn a result, which may be nothing at all. So we're just going to do that. So if I run this, we'll just have those 2 warnings, but nothing else. So if I do get cargo run clone, let's clone this. And I want to put this into desktop like that. Obviously, you don't do anything, but okay. So we have some warnings. Let's. Okay, so you should be happy. No more errors, no more warnings. Now this doesn't obviously do anything yet, but what I can do is we're going to play a little bit of the hostile developer pattern here. Well, we've kind of been doing that the entire time, but for those of you who didn't see a while ago, the hostile developer pattern is it's a TDD methodology. I don't know if I don't think there's an actual official name for it. I think that's something that we made up when I was teaching it. But the idea is that we have our TDD, that's the tests that are created by code crafters for us. And I'm the hostile developer. I'm going to write the bare minimum code that I need to write to get the test to pass, even if it's a poor implementation of it in real life, because that would then force the tester, the person writing the tests, to then write better tests, which then forces me to write it so we handle all the cases. And it's one of the ways that even if you're the solo dev, you can like basically switch back and forth between I'm the tester, I'm the hostile developer. It's like, okay, well, what if I just write the bare minimum? It's like, okay, well, now I have to write a test to handle that case, or like to force you to write it in the correct way. And I love doing that whenever I'm not sure of what to write, even if I don't have like all the tests written for me, I just like, okay, let's write the test for this. And it's like, okay, I'm going to hard code what I'm returning. It's like, okay, fine, you're doing that. And then go back and forth. It works out surprisingly well. Okay, so this is doing nothing is what we're doing. And we're going to go ahead and push this up, and I want to see what their tests are yelling at me about. Okay, so first off, okay, so stage 6, so stage 7, running tests for this. What ran? Oh, look at this. Okay, so it's going to Codecrafters.io get sample 3 is what they're using. That's good to know. Also, notice that they did not add in the .get. That's another thing I wanted to look into, is they didn't add in the .get. So if I go there, this is the repo they're looking for, and they have a bunch of folders and files here. A bunch of nested stuff. So inside of donkey. Okay. So now that we know that, we can start using this as our own. So this is going, we're going to clone you to desktop, get sample 3. Okay. Oh, and then tester repository does not exist. Test failed. So my guess is they attempted to CD into tester and that failed. That's my guess. So we're going to first create the tester, and then I'm just going to keep on pushing these up to like see, okay, what's the next thing I need to do? What's the next thing? We're going to do bare minimum coding to get through this, because if they claim it's really hard, then that's what we're going to do to make it bite-sized chunks to not get overwhelmed by it. Okay, so in clone, I want to create the directory, which means we need to create this as a path. So this is is it a target directory for that? So let's do okay, so that gives us a path buff. If this exists, so if this does not exist, we want to create it. So let's Let's go to utils. Do I have a create directory in here? I don't think I do. No. Okay, so I want to, what did we do? We did this before, I think. Yeah, so we want to do this. If not exists, so if not path dot exists, then we're going to do the standard fs dir builder new create ended in the path and do that. Mismatch types expected to result. Oh, yeah, then we're okay. That. So that should, okay, so now we have create directory. Okay, so you're missing an argument. Can I just do start from here? I think that works. Start from here and then go from target directory. Okay, so I want to okay, this is all we have on my desktop right now. And then I want to do the same thing. So we're going to do a cargo run clone to desktop get sample 3. So if we run that, and now we have a get sample 3. And if I run this again, it doesn't error out, and the directory is still there. So good. Let's find out what they're planning to do with this directory. Oh, okay. So they don't try to go into it. Interesting. Or maybe they are, but they're not really showing me. So repository does not exist. So my guess is that I now need to create like a .git or something on it. Probably. Interesting. Okay. So that's where we probably get to start looking into what are we trying to do here. And I guess I could go and get init inside of it and just run init. And that kind of would work, right? Okay, so what if I do, now we have an init. But my pub function init, you're creating a directory from this path. So yeah, we need to update all of these to handle just somewhere else to go. I'm starting to feel it though in my head, like getting a little bit tired. So I don't know how much longer. I have, you know what? I have 3. Can I snooze? Oh, it just started. Okay, never mind. We have an ad break that just started. So I'll probably go for another 20 minutes or so, and then we'll probably have to end because I'm starting to feel it in my head where it's like, ooh, this is starting to get tough to think. Okay, so I'm thinking we're gonna need to do an init. My guess is we need to do an init, and then we need to go and just grab what they're doing and throw everything in. But I'm curious about. So this is the URL format. So that's the HTTP protocol. Dumb HTTP clients must make a GET request to get URL info refs without any search query parameters. And then, oh, look at that. This looks interesting. Okay, so a GET request is also what the browser does automatically. So if I do a get URL info refs, so I just want /info refs, and we know we're coming here. So if I do a get URL to get sample 3 info refs. Oh, GitHub.com no longer supports get over dumb HTTP. So do I have to go to .get here? No, it doesn't like that. Okay, so I can't use dumb clients. I have to use smart clients. Service equals service name, where service name must be the service name of the client that wishes to contact. The request must not contain additional query parameters. Service equals get upload pack. Can I just okay, service name. So service equals. Can I just make that whatever I want? I did not like that. What did I do wrong? Let's go. Okay, so hold on. What are we? Yeah, so go to the get URL, info refs service equals. I guess let's try get upload pack. So info, is it ref or refs? It's refs, then service equals. Okay, so it doesn't like that. I want get upload pack. Ooh, okay, that. Okay, so that gives me this. So that gives us a, that looks like a mode, a hash. So what is it? 1, at 20 right here. So that's more than a hash. This looks like a commit hash that tells me which one head is on. And then it also tells me the branch probably. So the commit, the branch, and then is that null? So smart server reply 000. Okay, so then here's the different, okay, so we have different services. Smart service, do we have, well, there's no table of contents in here. Okay. Then, okay, so clients must first perform ref discovery. So we did ref discovery. So we got that. Oh, and then we're gonna have we have and we want. To do, document this further. Oh, great. That's love. That's lovely. Is there a smart service get receive pack? What did I? Oh, I did publish pack. So maybe I want get receive pack. So get. Ooh, it's asking me to sign in. Oh, wait. So publish path. Okay, interesting. I thought I got this working once and then it gave me stuff. Well, it gave me the download. That's what it was. It gave me the download and we saw what this was. Oh, from the upload pack. It's not publish. I want upload. And so that gives me, okay, that gives me a download file. So that's lovely. Very lovely. Okay. So let's see. Then you are create protocol packs. Okay. So we're going to have to go back and forth. We're probably going to have to do multiple HTTP requests, it looks like. Wonder if we're going to want to do a no depth request. Probably, because that will make it easier for me, I think. Let's see. Do you have any? I want to look for the packs. Chompkey Seal. Hello. How are you doing today? It might be worth looking at libgit2. What's a libgit2? Is that a library for getting stuff from Git in crates? I'm probably not supposed to use that because that's probably the entire point of this is to manually implement it myself. As like that's part of the challenge. Okay, so do you have like a list of? I was hoping for a list of the packs. I don't see that here. Oh, libgit2 is a C implementation used by some large projects. We found it helpful to figure out how Git structures some things, which is probably what we're gonna. Well, is not probably. That's what we have to do because that's the entire challenge, I think. Okay, so then there's okay, so a lot of these for different pack files. Okay, that's great. Do you have like a README? No, you don't even have a README. Okay. So I think what we want is that Git upload pack, which gets us this. My guess is then we can make a request to you to get the commit and say, I want this. I feel like this is what we want. Okay, so not deb clients, we want smart clients. Okay, so it gives us that. And we get, you. Okay, so we get that to get, oh, interesting. So we're going to do something like 32 want, and then that. And then, is that going to be a post request? Because I can't put this into the body unless it's a post request. So what were we using last time? I forget all the things that we've used. Was it Insomnia? It might have been Insomnia. Okay, so I'm gonna do a thank you. That's the default from Apple right now. So it's oh no, I'm not gonna do that. Okay, we're gonna start here with the get again. We're gonna recreate exactly what we have. So I'm gonna grab you. And so we get HTTPS github.com codecrafters example or get sample 3 info refs service equals okay, then we want to get upload pack, send that bad request. Okay, now when I hit refresh, interesting, that what was different? Okay. Oh, actually, no, wait. We have the URL they're gonna send to us. So that's in here. So they take us to you. Now then I want to go for info refs. Then we're going to go with a query parameter. Service. Now it can't just be anything. It has to be one of these services. So I want get upload pack. We get a 400 bad request. Now, if I do this as a post, method not allowed. Okay, so not to there. Now, the 400 bad request is interesting because that means I probably didn't get something back. Okay, the request must contain exactly one query parameter, service equals service name, where service name must be the service name the client wishes to contact to complete the operation. The request must not contain additional query parameters, so it's going to be a get to the get URL info ref service equals get upload pack. Okay. And then the smart, okay, so that's, I am, your HTTP 1.0, do I need to specify? Okay, so we get a 400 bad request out of that. Now we could try the dumb client again, but I don't think that, I think we tried this before. GitHub is not happy with it. So if I just do the get info refs without you. Yeah, okay, so please upgrade your client. No longer supports get over dumb HTTP. So let's, now where does this go? Oh, I need to use HTTP instead of HPS maybe? Oh, and then I need to add you back in. There we go. That's it. Okay, so not HTTPS. We need to go at HTTP. Okay, and this is what we get back now. So we get our service, get upload. The first part of your new UI feature is working. Excellent. That's great. Okay, so we get our head, multi-act, okay, then blah, blah, blah. We get this. And so this looks like the commit SHA. So object format SHA-1 agent get GitHub dash blah, blah, blah. Okay, so then now I want to request this. So then we have to do a request again. Okay, so after we got that, okay, so clients must first perform ref discovery with that. Now, what's interesting is that they have these wants and haves. Can I do this with a, so it says it has like the wants and haves in a, in the body, which doesn't feel right. That would basically say, hey, I could do like a post to this. Oh, the post works, which then means I can have this in a body. Where's my body? Wait a sec. Oh, JSON. Here it is. JSON. So then inside of here, we're going to have Clients must send at least one want command in the request body. Clients must not reference an ID in a want command which did not appear in a response obtained through ref discovery unless the server addresses capability. I wonder if we can get lucky with this. So can I just say want? I want this. Interesting. Okay. That don't think that gave me anything different. This looks exactly the same. Oh, do I have to do it like 0032 want? What was 0032? It was something. That doesn't change it. Okay, so you allow reachable SHA-1 and want. There's also this. Okay, I'm also curious if we come back to here. The most recent. Can I see what the most recent commit was? There's 2 commits total. It's 23F. Which is right here, 23F, which is also right here. But that didn't change anything here. If I did, okay, so 20, so. Oh, but 20 might be 2 of them, right? It's like every 2. Okay, so that is 20 bytes in hex. So the want doesn't work the way I want. Or rather, I'm doing it wrong. Get documentation, that's not helping. Get format. Can we see what want looks like? Pack files. Okay, so reading through this might be really good to grab, but what we need to do is we need to get the pack file itself. Unfortunately, this doesn't show us how to get that. Maybe one of these comments does. Let's see, was there more? Nope, that was get commit object still. Okay, let's take a look what their AI guide says. Yeah, so read through the provided resources, make a request to, okay. Yeah, okay, that's not helpful. Okay, yeah, so this person used Wireshark to, like, I was actually thinking about that. It's like, okay, we could use Wireshark to figure out what they're sending to GitHub. So it is going to here. Oh, well, I don't want to do that while live. We have this Stack Overflow. Okay, so here's the request that we see. The git docs and meta gives an example, the post request to send. Oh, and then to do document this further. Yep, that's what we saw. Okay, they try to curl. Oh, wait, I need to send in every check. Okay, so 00 is a flush packet, so I need to send in a 001. That's a delimiter packet. Do I need to send that, or is that them sending to us? So you're sending 1.5 lines, you're expected to do multiple iterations. Oh, there's this protocol v2. Okay, so I can request. Is that a question mark? That's a null. Null. Wait, is that what I was looking at before? No. A client can then issue a request to select the command it wants. Okay, so that's what I want. I want to then select that. Fetch is the command used to fetch a pack file. Okay, so I want to do fetch. Okay, so how do I tell it? I wish that they would like give me an example. Oh, but I'm okay. So unfortunately, I don't see exactly what this needs to say. I think what I'm going to have to do is do the exact same thing that this person is suggesting here. Although this is also okay, that we could take a look at this. It's written in Haskell, so we might have to read Haskell stuff, but that's no problem. So this is okay, that's what we saw. Oh, wait. This is different. To initiate the ref discovery, the client establishes a TCP socket connection to the server on port 9418. Wait, is that actually okay? Interesting. Oh, okay. So we might have to read through this to figure out what they're doing and then try to recreate this with curl just so we can understand it fully. To just send something like this to it. That's really interesting. Super interesting. Okay. Okay. Now, if I try to send a post to that port, so 9418. Okay, 9418, a post to here. I don't think we're going to have JSON. This is just going to be raw. I want I don't even want text. I guess we can do plain. And then we're going to send something like I want the want. Oh, this isn't sending me what's, oh, here it is. So yeah, we want like 077 want. Oh, for like the size of this. Okay, so let's do 0032 want. And then the hash. So that. And then the hash is 40 characters of this, which I think is 3F, 0B, this one right here. And then clear that out. That may be very unhappy with me. It didn't tell me no right away. It's interesting. I'm kind of surprised it didn't just kick me out right away. Do I want to flesh the end of the command for want? It didn't really say. Or at least I didn't notice if it said. Okay, so 32 want, and then that, new line. And then, okay, 000. So that's what I want. Timeout was reached. Okay, so I want that, new line, 000. Our content type has to be application xget. Okay. So let's set a header for this. Okay, let's try that. And then I wonder, can I make you? I could do other too. Oh, I guess this is what's setting the content type. Okay. It's not happy. I don't think this should take that long. Now let's try not on this port. Ooh, okay, so back to this again. Oh, but should it be 03? Let's try this thing. So in my I want 003F want like that. Okay, so post to get URL, get upload pack. Oh, to slash get upload pack. Okay. So to that. So let's do our, what was it, 9432 or something like that? 9418. Yeah, so it lets me send this to them, and then it just sort of hangs there because it's not happy with something that I'm trying to send. I probably want to send this as a 032. So let me cancel and try this. Yeah, it doesn't like this either. Let's try a new line here. Now I do have a space, right? I do have a space here. So 03. I wonder, okay, so oh, where was that example? What's 0032 in hex? Oh, wait. Okay. Was it not that one? Got you. Got you. Okay. So it does. Oh, this one. Okay. So post to get URL, get upload pack. Probably make sure that I'm running on HTTP 1.0. Is that even possible? How do I tell you? See, I don't want auth. Yeah, I don't know how to tell it. Send. Yeah, okay. Okay, content type application. Okay, so we want to make sure that content type is set to this. Content type is set to that. And then our body is going to be, okay, want with the commit. And then I don't have anything, do I? Albert, welcome back. So want, do I want something like that? Want this thing. And it's not really helpful. Whatever this is, nope. I want. Okay, I want the full commit SHA. Can I please see the full commit? Oh, here it is. Okay, just to make sure that that's the same. Now I have a new line in here, so that might just work. But I don't think it is. I think it would be responding if it was correct. Okay, so what I think we need to do, and my brain is not working correctly right now because we've been streaming for a long time, almost 6 hours. So I think I need to take off for the day. Next week we're going to continue on this. So I'm doing this on Mondays. I'm hoping that we can get this done in next week, but this is a pretty hard one. So it might be another multi multi-day one for us too. I am working on, after a thrilling 8 minutes of bicycle from school to train station. Oh, right, you're on a train on the way home. Okay, so yeah, we need to set things up. Oh, I probably don't want a query. Yeah, so I need to, I think, look through, either we're going to look through other people's code in Code Crafters here, which might be the best way to do this, just to sort of see how to send the initial request. That's probably where we're going to start is like look through code examples. If we need to have other things, then we will have to, let's see. ProGit is not been, well, I guess like we could look at the ProGit book as opposed to looking through this Git SEM, because this has been pretty bad. The dumb protocol is described. Unfortunately, dumb GitHub is smart protocol, so we can't use that. And this is very awesome because it has in here several times where it says to do, document this further, which is great. And like, I want, yeah, really great indeed. I want to be able to do this. So like, this is what it looks like I should be able to get. And then we sort of like parse it through, but we're not getting that out. We once took a shot at reading the Kafka protocol like this. It was so much scrolling up and down to parse through all the versions. Yeah, I know. Like this part, yeah, to do, document the response. It's like, oh, great. Okay, thank you so much, Git, for that. All right, so so what I'm thinking is that I need to go off just to rest my brain, because like, as you can tell, talking is starting to get hard now. So that's fun. Zilby is still down here on my chair though. So what we're probably going to do is we're going to read through some of the code next time to sort of see what people are doing. Specifically, what I care about initially is just what the request is like. And so finding that. And so that's all I want to see is just the request. And there's a lot of here which I'm not necessarily, okay, here's like request. So here's starting to get request stuff. So fetch refs. Yeah, okay, so this is that first one. We're going to the info refs service get upload pack. It's a get to this request. And once you get that information, we then need to do another request. Okay, so they're going to get the hash. Okay, we're going to get the refs. Okay, don't care about this. I just want the next request. So assuming, okay, so fetch pack. So we're going to okay, so It's going to go to a URL somewhere. So I do a post to the rec. Here's that application X body. Okay, then we send. Okay, so then we need to find, get HTTP protocol. So get blob. Oh, wait a second. That's how I can get to it? I vaguely remember seeing blob before. Okay, that makes sense. So can I just ask them? That feels like it might be cheating, right? Okay. Anyways, yeah, I'm tired, so I don't think reading through this right now is going to help out very much. I don't think it's actually going to get me what I want to get, at least right now. So, I'd say this is not cheating. This link is a link to a file in the official Git repo. I mean, yeah, that's true. The official Git, yeah, I guess like if I could go straight there, like I think that if I go to, like, okay, so here we get to commit. If I say I want a blob, like if I say I want to go to like this specific file, take me back to here, the code. Yeah, notice tree. That's super interesting there. So blob, branch, and then the path. So what we saw here in that code example is like I might be able to say, get me now, like if I get the hash of what this is, like get me what that thing is. And like if it's a commit that we see from in here, that I also see in here, then I might be able to just say like, hey, give me this thing, where it's like, okay, give me that. Which that gives me the commit. So, and I just need to tell it to do something else. Oh, I commit. Oh man, I went another full hour. Oh, the link is to give the official documentation. Okay, I wasn't paying attention. That's my brain being too tired. All right. The ad, I waited too long for the ad break to start, and I forgot to cancel it, so I can't do that right now. All right. So for everybody who is here, thank you for stopping by. Sorry that I accidentally started an ad break that you won't be able to hear because you're probably in the middle of ads. For everybody else, thank you for hanging out with me today. I need to go rest my brain. I'll go ahead and get this set up and going. If you've enjoyed what you're looking at, if you want to do these type of challenges yourself, then I do have this code for you, which is Code Crafters. Also, the code is in the YouTube description down below if you're on YouTube and you want to look through this. I am partnered with them, so if you do use that code, I do get some money back for that, which is one way that you can support the stream if you want to go with this and you want to try it out. Let's see. If you have any questions, any thoughts, comments, I'd love to hear them in replies or on our Discord or anywhere else. And with that, I think I think we'll just let the ad break end, and then I'll let everybody on Twitch know that we're ending too. So, yeah, that's pretty much it. Well, we have 30 seconds more, and then we'll be done. Here, I'll get Zilby so we can all look at him. Hi. Skimus, thanks for the stream. Yeah, absolutely. Thank you for hanging out with me. All right, welcome back, everybody who got. I meant to stop the stream before the ad break started. Sorry about that. So, anyways, I told YouTube and everybody else who didn't get the ads. But I'm gonna go ahead and end the stream now. Thank you all for hanging out with me. We'll figure out. We'll continue with this project next week on Monday. And until then, tomorrow we're going to be working on the Docker course, and then Wednesday we're continuing to play the assembly game, which is fun to say that we're playing with assembly. But yeah, so anyways, that's what we got here. Zilby's done with me, so with that, have a great rest of your days, and I will see you next time. Bye.